Morning, everyone, and welcome to our weekend course, Innovation Management for AI. This course takes place in parallel to the mandatory internship that many of you are doing. However, I know some students maybe not doing their internship at the moment. They may have done it already, or they will do it sometime in the future. Who of you is currently doing an internship? Okay, so almost all of you. And we have a few students online, and I'm very happy to see that we have a large majority of students here on campus, because I think this will help for the interaction, and we will have some guest lecturers this weekend here already. However, if I notice that lots of students don't return from their lunch break or are not returning tomorrow, we may not stream and record at all anymore. So I would be very happy to see all of you here on the weekend. I will be teaching most of today. In the afternoon today, we'll have a few guest lecturers, and tomorrow I'll be teaching, and tomorrow morning we will also have a guest lecturer. A very famous person, in fact, is coming tomorrow, Christoph Zindel. He was a board member of Siemens Healthineers, and he will share some insights tomorrow about commercializing medical devices using AI and that kind of stuff. And he was a board member of one of the largest companies in the world doing that kind of stuff. So that's why as many of you as possible should be here, since Christoph is coming, and he's a very busy person, sits on the supervisory boards of numerous large enterprises now. So I'm very happy he's coming here tomorrow. And today we'll have another few excellent guest speakers. So what is this course about? You have taken plenty of very technical courses so far. I know most of you who are sitting in here are in the German language or English language AI undergrad programs. We have maybe a few exchange students taking this course as well. Are there any exchange students here? Okay. Quite a few, actually. That's good. And so this course assumes that you at least have some technical understanding of AI, because we will look at AI largely now from a management perspective. And you have had so far very technical courses. And with those very technical courses, you learn how to build AI systems, assistance systems, logic systems, vision systems. You had an intro to AI, you learned machine learning, you learned natural language processing, and I hope most of you have so far completed these courses. And now most of you are doing an internship in which you're working on real world problems. And when we look into the news, and that's what you're also being told maybe in an introduction to AI course, you see there's lots of news around AI. Lots of papers, lots of interesting things. And it seems like AI is really working, but what could happen in reality so that AI systems do not work? So I want to engage in a lot of discussions here this weekend with you. So what do you think, what you see from the news about AI working or AI not working? What do you think is the majority of the news at the moment? And what have you noticed during your internship? Yes.
AI not working, or more than cherry picking the cases where something bad happens due to AI's fault. But I think the silent majority of cases where AI is used in the background is just working fine.
Okay. So I will just repeat this so we also have this in the recording. One student says that the news seems to cherry pick things that do not work, yet he feels the large majority of AI applications are running silently in the background. Any other views? Yes?
I think it's quite the opposite.
Okay.
I personally get a lot of good news on AI. Every day there's something new AI can do now in various fields. But I think it's a lot harder to actually integrate these solutions into the working system.
So we got quite the opposite opinion from another student saying the news seemed to be very positive, yet it's more difficult to get the stuff up and running. So we see there's quite some disagreement. Any other views you want to share? Maybe something you have noticed during your internship that something doesn't work as expected or is working better than expected? Fine, we'll see later. So why are we actually doing this course in parallel to the internship? So this is one of these two internship accompanying courses, and usually they're either before the internship, so during the summer break, or after the internship, sometime in early March. I do this course in parallel to the internship so that you actually can already contribute some real world experience, plus you still have some time to maybe reflect some of these learnings, and that could help you during your internship. And that's why we are doing this during the term. So we have to do this during a couple of weekends. I will tell more about the organization of this course later, but we see some very recent news. There was an MIT report now during the summer break that said 95% of Gen AI pilots at companies are failing. Anyone saw this in the news as well? Okay. So I have lots of references here, so you can read this in detail, but it's actually nothing new, these numbers. So actually the numbers seem to get worse and worse if you look into the news. So I started teaching this course for the first time 5 years ago. And at that time, often that percentage was something like 80, 85%. And we'll look at a few numbers, and then we'll look at the underlying reason for these numbers. Like there was an IBM report a few years ago that said 85% of organizations across industries, they see AI as a strategic opportunity, but only 1 out of 20 has had so far extensively incorporated AI in offerings or processes. That was a few years ago, but we'll see more of these numbers. And what that IBM report also reported was something like 80% of AI projects fail, or they don't get off the ground, specifically due to a lack of data. Another figure says 80% of organizations don't understand the data required for AI. And there was another number in a different report a few years ago that said something like 85% of AI projects would not impress CIOs, so chief information officers, while 75% of real AI projects under helm. And there are some other interesting figures. So in 2016, Gartner reported that 60% of data science projects fail. Then just in the following year, they said the fail rate was something closer to 85%. And then in 2019, VentureBeat reported 87% of data science and machine learning efforts fail and never impact business. So I saw the shades just closed. Let's try to open them again, because I was wondering why it was starting to get so dark. So the numbers seem to get worse over time, starting at 60% failure up to 87 and then 95% failure. Now, obviously, various terms got mixed up. This is about Gen AI. Some of these numbers are about data science, machine learning. So it's also different terms. But do you have maybe a suggestion why this failure rate seems to be that bad? Yeah.
Because the AI is so new today, and some complex tasks are not still understandable by the AI.
Okay. Any other views? Yeah.
Some tasks aren't really fit to be solved by AI or are fit to be solved by another system better. But the companies or the projects are like, we want to solve it with AI, we want to do it this way, and they don't account for other possibilities, and therefore they don't work.
So one comment was that people are looking for AI projects, while AI may not be the solution, or there could be other or better solutions to a problem. Yes?
More AI solutions are very customized, but some data industries need more customized and client-oriented solutions.
Okay, one would need more customized client-oriented solutions. I think you had also raised your hand.
The effort put into it is sometimes not enough. Like one of the slides said, many companies underestimate the sheer amount of data necessary for AI, and I think that's where a lot of these projects fail because they just underestimate it.
Okay, so companies underestimate the task. They may not be ready. Obviously, the number of AI projects since 2016 has gone through the roof, and the number of experts has not grown adequately. Now, everyone on LinkedIn seems to be an AI expert. If they can write AI, they're an AI expert. And I too have been invited. So I'm often invited as a speaker to events, but sometimes I see other speakers too. Like last year, there was a very, very large bank, one of the largest banks in Germany, and they invited me as a speaker. And before they invited, so I gave a more specialized speech, and they invited a professional keynote speaker for the keynote, but the guy really had no clue about AI. And just a lot of buzzwords mixed up, made a huge impression. And if you check his LinkedIn, he claims he's a big AI expert, but none of the stuff in that keynote actually makes sense. But he was somehow able to convince others. And I think the number of those people is growing enormously on LinkedIn. So that's also a problem, because AI, there's a lot of money around AI now being made, and that attracts a lot of people to that field, but they may not have the necessary skills. So I think it's a huge opportunity for you. You're studying AI here, and there's a huge demand in industry. So, but some of the comments you mentioned, I would also, or I think I agree to nearly all what you said. I often get invited by companies. They tell me they want to do AI, but AI may not be the solution to their problem, and you need to solve the problem as simple as possible. And sometimes you just need to rethink that problem, or you need to rethink processes, and an AI will not just magically solve all your problems. But we will discuss this in detail in these 2 days. This was just a motivation to look at some numbers. And the transition to becoming an AI-driven company is also very tricky. So there was a post on Twitter a few years ago. So this guy here said, as a rule of thumb, you can expect the transition of your enterprise company to machine learning will be about 100 times harder than your transition to mobile. And a lot of companies or big corporate are still struggling to transition to mobile, have maybe a very old intranet space that you can only run on your laptop and so forth. And the transition to becoming AI-driven is obviously far more challenging. Then there are a lot of hypes around AI, like this one here. Has anyone ever heard about AI washing? Nope. Yeah. So AI washing means you just do something relatively simple, but you just build, a few rules or something, or you just have a if else, and then you claim you're doing AI, but in fact, it's not AI. And a lot of people outside our domain, they mix up lots of stuff, like lots of terms like AI, algorithms. A lot of people use them now as synonyms, but they are not synonyms. So that's very important. So sometimes very simple things are just rebranded as an AI, which again contributes to the hype. Then there's obviously a huge hype in consulting around AI. There are a lot of consulting companies. Some of them are doing great work, but a lot of them are obviously just making things worse, building nice slide decks, but with little outcome. And we just skip through this. So what is this course actually about? For this course, I assume you have your technical expertise in AI, and we want to understand business potentials and how we can commercialize AI and how we can add value in companies. We will see why many AI projects fail, and I want to show you how to implement AI projects successfully. So we get from a 95% failure rate, maybe to a 95% success rate. That's something we want to achieve. And you can make lots of money once you know the technical stuff, but also how to bridge or build that bridge from technical expertise to creating concrete outcomes. This course is an intensive course of 3 days. Why is it 3 days? Because we blocked 6 days in the schedule. Today and tomorrow, we're having this lecture here for which most of you are on campus. Actually, I expected more students would be taking the course because we have, I think, quite a lot of students in the English language program. So I would be happy to see most students actually here in class for the lecture part and not only get to meet them once we have the seminar presentations, but there are some updates to the seminar part as well, some new rules. And we have these lectures here today and tomorrow. And then in December, you will present your case studies. I'll say more about the case studies later. And in December, we have 2 weekends for these presentations. Concretely, December 13 and 14, which covers, or for which we have slots for the students of the English language program and exchange students and all other students, except the ones who are in the German language program. For those students, we have seminar presentations on December 20 and 21st. If you have mixed groups from these different degree programs, we'll just see where the majority of students of a group fall in, and we'll try to assign you to the right weekend. And it's 3 days for you, it's 6 days for me, because you're supposed to be following the lectures today and tomorrow, plus attend all the presentations of the day on which you are presenting. So you don't need to be there for these 2 weekends, but only for that 1 day on which you're actually presenting. These are group presentations. I'll say more about that later. So make sure you block these weekends for you, or the weekend today, as well as one of these weekends in December. You find all the course materials in this course. It links to my Nextcloud, so you find the slides and lots of supplementary material. And we have the course carries 3 credit points. And in your presentation, you will present a case study, and you're very free about the case study, what you're working on exactly, but it has to fit to this course. So your case study would be about some company, either where you're doing your internship right now, or some other case that you find on the internet about an AI transformation or an AI project in a company, what typical challenges could be in order to commercialize this or make that project work, and how you would solve these issues. That's something you would be presenting. So your presentation should not cover only purely technical aspects, but also management issues that we will discuss in this course. And your presentation will take 15 minutes. Your groups of 2 to 3 students. And after your presentation, there will be a 5-minute Q&A session. And since this is an internship accompanying course, it's only a pass or fail. You need to sign up for this on Primus. You need to register for this internship accompanying course 1. If you don't register, but you sit the exam, your mark will just be invalid, because every year it's lots of work for the assistants in the Center for Studies to add marks manually for those students who took the course but didn't sign up for the examination. So make sure you sign up for the examination. For any questions on how to sign up for the examination in Primus, please ask the Center of Studies. I have no access to that portal, so I just don't know. You won't be able to register right now yet. I don't know, the registration for exams is always sometime, I think in November or so, but for any questions, just ask the Center for Studies, because I just don't have access. So the timeline is the following, the schedule. Today and tomorrow we have lectures and guest lectures. And you should already start thinking about a case study today or tomorrow of how you would implement AI in a company. As I said, you can pick a company you've been working at or any other company, and you can pick examples that you have come across personally, but also examples that you find online, for example, in reports from consulting firms, or we have lots of references here about an AI transformation of a company or an AI project, what typical challenges would be and how you would address them. These challenges can be legal challenges like data protection, AI regulation, can be hiring issues, can be requirements issues, whatever. So there's lots of flexibility, but please don't present a purely technical case study in which you show us in detail how you implement an AI, because the course is not about that. That's what you learn in other courses. And I've written that here, and you need to register your topic in iLearn by a specific deadline. And the deadline is concretely Wednesday, November 19. You need to just submit the names and student IDs of all group members, which is 2 to 3 students, your topic and your degree program. And I need to know your degree program so I know to which weekend I can assign you. And if you mix groups, I'll just try to find the best solution. Unfortunately, in the last few semesters, I made a few very sad observations when it comes to seminar and project presentations of students. And I want to share some of my observations with you because they have unfortunately led to more rules for the seminar and project presentations in all of my courses. I have noticed in the last few years that a lot of students try to choose the date or even the time when they want to present. A lot of students arrive late just on the day they are presenting, like 20 minutes before they are supposed to present, and they leave after they have presented. I'm telling you, when I studied less than 20 years ago, no one would have dared to do that in a seminar. And a lot of students do not attend the other presentations on that day. And the presentations, they're not really just for me, they're rather for you to see lots of other stuff. And it's not just this course, it's other seminars, projects as well. And there are plenty of excuses, like bus was late, grandma died. You can't believe how many grandmas have been killed by my courses. Or excuses like students live in Munich. And I also notice every year in the seminars and projects that there are quite some students, they have not attended the live lectures and not watched the recordings at all. And these observations, they're very sad, because I didn't make them when I started here 5 years ago, or not to that extent. And they have led to a few new rules, and I want to communicate them very clearly, and there are no exceptions. So these seminar presentations in December, they take place on campus, very importantly, not online. If there is a student doing the internship really outside Europe and is unable to come here, we can find a solution and make an exception. But if that's the case, you would need to get in touch by email and clearly demonstrate proof that your internship is abroad or outside Europe, whatever, so that you're really not able to be here for the seminar presentation. And there are a few more rules that are very strict now, but it's the only way to make these observations go away. So do not try to negotiate the scheduling of the presentations. And you need to attend all presentations on the day of your presentation. If you arrive late, meaning 8:01, you will not be able to present and fail the course. And if you're not there during the day, and I noticed that, like at the last presentation, you will fail even though you had presented before. And the Q&A session may cover everything discussed in class. But I think you would also be happy if lots of students sit in your actual presentation and that you're not just presenting to an empty room. And it's rules we really did not need 5 years ago, but this problem has become bigger. So we have these new rules, and not just in this course, in all of my courses. So, and no excuses, focus your time on delivery, because I get lengthy emails every year from students explaining me all sorts of stuff. But always think about this is your probation period in a job and you're late to a meeting with one of your clients. I don't think anyone really cares about excuses. And as I said, if your internship is really outside Europe, whatever, please get in touch. But when I looked at the internships, because since I need to sign them in Primus, there were rarely any such cases. So you should be able to be here. So these are the rules. I just wanted to communicate them clearly so we're all on the same page. Don't be late. I'm also not late. And don't leave early. And there are some excellent books for this course that I can highly recommend to you. For example, there's the AI Superpowers book. Anyone knows this book? It's from Kei-Fu Lee about AI in China, because we will also look at some international developments on AI. And I spend quite a lot of time in China every year. So I like this book here, and we will be discussing some of it. And obviously, the content of this course is based on lots of references. So there are not just these 3 books. The book here to the right is called Data Science in Context, which I find very helpful. It's about foundations in data science, which you possess already, but also about challenges and opportunities. And the book on the left is something I published a few years ago. And there are also some best practices about AI in a commercial setting. You don't need to buy this book. You don't need to buy my book. The key chapter of my book is something you can find in Nextcloud, and the other 2 books, obviously, if you buy them, they will provide lots of references, but you don't necessarily need to buy them for this course. And here are the references, but there are lots of further references for some individual slides. I also noticed one thing. So I wanted to update these slides during the summer, because I always like to upload updated slides long in advance. But there were just too many news during the summer, so I was unable to produce a slide deck that was ready in summer. I took lots of notes and made lots of changes, but I only uploaded the slide deck a few days ago, because I guess with my other courses, you have noticed the slide decks appear earlier. But here it was just not possible because there are just too many news in a short amount of time. Are there any questions about the organization of the course? I'll also check here in Zoom. The whole case study thing is something we can talk again about tomorrow. I guess we first need to progress with the content of this course. If you look at the recordings of last year, I don't know if anyone has looked at them. Last year we had a very good course, but this year we have lots of new content. We will also be talking a little bit about AI agents. I've added more content on Gen AI. I've added plenty of more best practices. I've added also various reports about AI competitiveness in various countries. One topic that has got a lot of traction also from a legal perspective is AI at the workplace. And there are plenty of other additions and minor improvements. And before we look at the whole contents, we will just finish the introductory chapter. And I want to discuss a little bit with you how AI is changing your life. not just from a perspective at work, but maybe also in terms of your private life or any other news? Do you want to share some insights? So you're all studying AI, but you're also using AI as an end user. Anything you want to share how AI has started to change your life? Yeah.
Basically copyright issues because if you're using AI for studying and you basically input something to the AI then considers it as their property. Like even if it's your text, AI will still consider it as its own property and then so they are going to be the copyright.
Okay, copyright issues. Okay, how do you address them? So when you use Gen AI tools, do you pay attention to this, or what are the consequences of the copyright issues to you? Okay, so training the AI, that's an issue, or do you have a solution how to train it appropriately? Okay, no solution. Yeah, we will also be talking about copyright sometime today or tomorrow. Yes.
Personally, I would Google for searches, but now I think that AI can do a better search, like more targeted search. You know, every time now to find something, or there is, if I need something, I go to ChatGPT, Gemini, or whatever, and I just type it in and go to this one.
Okay, so you're using less internet search, but more Gen AI tools to answer your questions. Some search engines like Google, they have also integrated Gen AI solutions. And when you type in your query, I guess you've seen this as well. So it's maybe one way how you can combine both. For the students that are joining online, we have, I don't know, like 13 students online. Including some of them that I know personally and would be very happy to see them here on campus, but that's a different topic. Any other comments you want to make? Okay, so AI has changed my life quite a lot, obviously, in terms of work, but also in private life, because we use much more AI tools now, say in order to augment search, or if you go to a doctor. I bought a new car last year, so these cars have lots of AI features now integrated, which is mandatory. So for example, cameras and object recognition are now mandatory for the dead angle. So when you want to turn left or right, this is now mandatory for new cars in the EU, that you have a camera looking into these directions, plus an object recognition. So it's something I find very, very helpful in my new car since last year. It's mandatory, but you get used to it very, very quickly. So when I use my old car, which is now being used by my wife, that car does not have those features. And each time it takes me a little bit to get used to what was the state of the art 5 years ago. So one gets to adopt very, very quickly, but I really like these features. And the car also does nearly, or not fully autonomous driving, but at least some features that are augmenting. It's something I find very, very helpful because I spend a lot of time in the car every week. Just last week, I spent 3,000 kilometers on the road. I met various clients, went to various seminars, gave various speeches, was all over the country, including some rides in the night. And for that, these features that help me in driving, so AI-driven features, really make my life easier. Because if you spend 3,000 kilometers in a car in a week, it's quite exhausting, especially during the night. So something I find very helpful. I had some family members, they dealt with cancer in the last few years. So doctors are now, or labs are also using more and more AI in order to test samples. So it's something from which those people that were affected by cancer probably helped a lot. And I think we're just at the very beginning of all of this. We will probably have way more AI features in the coming years that help us in our daily life, like better cleaning robots and this kind of stuff. So it's something I'm very excited about. And any other comments? Anyone wants to share how AI is changing your life?
We are making our conversations more related to the prompts of how we are living when we are fine-tuning ourselves more with AI.
Okay, so we are fine-tuning ourselves to the AI, how we ask prompts and this kind of stuff. Yeah.
It's changed how I use AI. For example, ChatGPT. I wouldn't ask it with questions I have to be absolutely certain about. Because I know it's just probabilities, so I wouldn't trust it fully.
Mm-hmm. So it helps you to know how AI works, to use AI better because of statistics and so forth, that the outcome is not necessarily correct. Okay, yes? So fake content on social media went up a lot. Yes. Also on YouTube, there are lots of shorts that are definitely AI generated, but today you are still able to distinguish them, but they are also getting better and better, because I think in terms of image generation, a lot of generated images now really look like real. For videos, it's probably still a few years away, but there has also been lots of progress. So fake news around elections, whatever, is certainly an issue. Any other comments? All right. Then, before we dive into the main content of this course, do you have any examples of successful or unsuccessful AI projects or entire AI transformations of companies that you have in mind? Because the news is full of that. Something that really worked out, that something did not work out, something you have seen in the news or something you have experienced personally. I'd like to discuss this a little bit with you. Yes?
IBM is trying to use an AI to translate COBOL to Java.
Okay.
But if not fully functional, it still needs a COBOL engineer to correct the prompt.
Okay, so a machine translation service from IBM that did not work very well yet. Okay. Something else? Yeah.
I hear that, for example, the AI in the Google search, it's not exactly AI, it's just taking keywords from researches or most view page to put the things on the AI research.
Okay. Something else? I mean, there must be lots of news and yeah.
Somewhere in Galway or something, they now build or starting to build like fully AI or AI roles, not with like a controller somewhere in the background. Just they're now going into production, so currently testing went quite well.
Okay, so an example of fully autonomous robots that seems to go well. Okay, I have not seen that in the news, but obviously there's progress. Let's see a little bit in the chat. Samsung's AI integration compared to other phone manufacturers. Yeah, I think Apple is quite slow when it comes to innovation, and not just AI, but I feel all the iPhones that just look almost the same like the previous ones. So I think that delta from one iPhone or one iOS to the next one is not as much as it was or it used to be in the past. One student says he uses, so from the slide before, he uses AI to speed up his coding, writing, even cooking. Yes, so I guess most of us are doing this now to generate code or improve our writing, and I think productivity is going up massively. One example of a successful project is Klarna's service chatbots that do the job of 700 full-time agents which operates 24/7, so massive speed up. Yes. There was something like 10 years ago in the internet that I want to share. I found this quite interesting. So it was about Walmart in the US, and when you had a customer account, customer card, and you bought products, they would send you ads by mail still at that time, what else you would need. And there was a teenage girl who bought various stuff, and then Walmart sent her ads for products for pregnant women. And then her parents complained to Walmart, and it turned out, but in fact, she was pregnant, but had not noticed. And bought other food, whatever, and then the AI found a pattern and recommended something. So that's something quite interesting that was on the news probably 10 years ago. Do you want to share some other insights, maybe something you have noticed at work that worked out extremely well, or something that did not work out? Yes?
Years ago or something, Google, I think they use an AI classifier for their pictures to classify them, and they had a big scandal where they interpreted different skin colors and some skin colors with animals and classified things like people as gorillas or something. It was quite a big upset and quite a big catastrophe for Google.
Yes, a very good example. I'll just repeat it so we also have it here recorded. This was something about 10 years ago that Google added to their photo service a photo classifier that could classify images based on the main object, like a cat, a dog, a car. But white people were classified as humans, but black skin was classified as gorilla. That's something that led to lots of criticism. The underlying cause was actually a bias in the data. So the data that was used for training was not representative, and that caused a big scandal. Google claimed they had fixed it immediately, but I guess they just did not. They just probably disabled classifying or predicting the gorilla class at all, because you're unable to fix something like this immediately, because you need to look into your training data, whatever, and probably improve the data. So that was a big problem. I see lots of very successful examples also with companies that I work together. So in addition to my professorship here, I also run my own consulting business. And over the years, I've seen really, really cool AI applications that I build with my customers. For example, one of my customers, for many years, they built software for call centers, and they started integrating AI more and more over the years. So these call centers, they not just receive phone calls, but also emails. So one of the first steps years ago was to classify emails automatically and assign them to the right person in the service center. But then 1 or 2 years ago, we started integrating LLMs, and now a lot of these emails get answered automatically. That's something very, very positive. And now the next step is improving phone calls and automating them as far as possible. And there are now good solutions for that as well. There are lots of other projects I worked on. I'll probably talk a little bit about them in the next 2 days, but I think we're fine. Yeah, you raised your hand for an example. Yeah.
They back off from the idea quite a bit, and we normal people again in the support, because many of the customers didn't like it at all. And I think that will be something which more companies will do with the chatbots, but they will actually learn the same lesson as Carlos said. It's not the only way to only chatbots with AI. No humans at the other end anymore.
Yeah, so the comment was that Klarna then integrated more humans again into the process. So it's something like humans and AI-driven chatbots. Some things you can automate with a chatbot, some things maybe you cannot, or you need a human. I never really used Klarna. I have to say, I just pay my bills every month, so I never used that service. So I haven't used their chatbot. There are also lots of lists on the internet about AI failures. And what we want to do in this course is we want to discuss how we can actually succeed in AI projects and what we need to do in order to get from a high failure rate to a high success rate. And in this course, we will look at, first of all, some historical promises of AI, because there were lots of promises already in the 50s to early 2000s. I want to see how they have materialized. Some of them you may have seen already in an introduction to AI course, but we also have lots of students from other degree programs or exchange students. Then we will look in this deep learning era that we're in now. So we use lots of neural nets for example, Gen AI. We use AI agents. We'll see this. Then we'll discuss some best practices if you want to do an AI transformation of a company in terms of process models and so forth. We will also see some contemporary challenges that are currently there, like AI transparencies or explainable AI, international developments around AI. And one thing that has become bigger and bigger are now legal challenges around AI, and we will also discuss them. We will see if we finish everything in depth or not, because we have quite a few guest lecturers here. But we have blocked this slot from 8 a.m. to 5 p.m. on both days. We'll see if we finish a bit before 5 p.m. or not. We'll just see in the next few days. Yeah, history and promises of AI. We will start with the Dartmouth conference and see what that one was about. Then we look at some historical events in AI from 1955 to 2011, and we will look at the concept of an AI winter. So in 1955, a proposal appeared, a paper that was called a proposal for the Dartmouth Summer Research Project on AI. Appeared in 1955. Has any one of you ever seen this document? Should have been discussed in your intro to AI. Anyone has read the document in full? So not many. It's something you can find on the internet, and it's something I can highly recommend to read, because this paper is often considered to be the beginning of the research field of AI. So in 1955, the people that were leading in that field at that time, like McCarthy, Minsky, Rochester, Shannon, they worked on those problems in that time. That's why there are AI models or AI concepts from before 1955. And those people, they wanted to meet during the following summer, so in 56, for an AI summer seminar. And in order to meet during the summer, they needed research funding for that project. So they wrote a research proposal, what they wanted to explore during the next summer. And the document is quite interesting. I will open it briefly and switch the screen share. So it's not too long. It's just a few pages. In fact, this is not the original typeset one, but this is retyped, and it's something. So they propose different aspects. They want automatic computers. They want to explore how computers can be programmed to use languages. They also wanted to look more into neural nets, So AIs that can learn, AI that can self-improve. And so it's just a few pages. So if you have some time, you should read it, because I think it's a very interesting document, because it set the foundation for the field of AI. So they had big ambitions, computers that can work with language, computers that can learn. But they felt that building all of this was probably not that difficult. And they felt that all of this could be addressed or done during the following summer. And that did not work out, obviously. Today, by far, we have not solved machine learning yet. We have not solved natural language processing. And during that summer project, probably there were not many concrete outcomes. And that's something we see actually quite often in AI history, that very complex problems were underestimated and believed to be solved very, very quickly. Like nowadays, a lot of people think we are very close to the singularity, achieving artificial general intelligence just in the next few years. And that's something we've seen actually quite often, that very simple or that very complex tasks were meant or thought to be simpler, but eventually that did not work out. So there are AI works from obviously before 1955, because people worked in 1955 on AI. Do you know any AI methods that were already there, or something we count today into the field of AI that was already proposed before 55? Yeah.
Theoretical, theories about AI, and theorems.
Yes, Turing. Yeah.
You said I propose to consider kind of machines thing.
Yes. So Turing's work about the question whether machines can think. Yes.
What now we know as a perceptron.
Yes. The perceptron is something that was proposed at multiple stages by individuals, but there are some works from before 55, or something that we use quite often. PCA, so the principal component analysis, is something that was described before. And there were actually quite some works from before 1955. For example, the checkers program in 51, the Turing test, early neural networks. So you mentioned the perceptron from the 40s, but some of that may have been proposed multiple times. Then in 1770, the Turk. Anyone knows this? So what was the Turk?
It was like a magic trick, because it could play some game, and in the end it turned out that it didn't really have intelligence. It was just like if or else statements, or in principle if or else statement, but it looked like AI. I think.
Okay, let's collect a little bit. Yeah.
One person on the table, was seeing the endpoint of the figure from the other side, and then control the puppet to play the chess game.
Yes, that's what I also remember. So it was a machine, or a huge box that was claimed there was a machine in it that could play chess, but in fact there was a human inside that box and moved the chess figures. So that was a fraud. And there were obviously earlier publications like L'Homme Machine by Julien Offray de la Métrie in 1747, and lots of other works. So the field of AI existed before the Dartmouth paper, or before the Dartmouth proposal, but the field as such, as a scientific field, where its foundation often goes back to 1955 because of this proposal. And something I notice from the 50s to 70s, there was lots of optimism around AI. For example, Simon and Newell, they wrote in 1958, so I'm putting the quotes here, within 10 years, a digital computer will be the world's chess champion, and within 10 years, a digital computer will discover and prove an important new mathematical theorem. So this is something they predicted in 58. Did these two predictions work out? So
is playing chess, but not as a chess champion, but it is reaching to the level of the chess champions that we humans, I think.
okay. But did that happen within 10 years or later? No.
Recently, 2000s, yeah, early 2000s.
So when was Kasparov defeated? Anyone remember? This was sometime in the late 90s or so, mid to late 90s. Kasparov was the best chess player at that time and was bet by the IBM Deep Blue. So it's something that took 40 years rather than 10 years. And automatic provers and this kind of stuff, or for math theorems, it's something that happened later, but not within 10 years. Simon also predicted in 65 that machines will be capable within 20 years of doing any work a man can do. Nowadays, you would say a human can do. Did this happen? And we're still not anywhere near there. Minsky said in 67 that within a generation, the problem of creating AI will be substantially solved. So a generation, say 25 to 30 years. Well, now it's almost 60 years later. We're not anywhere close to having AI solved. And then Minsky said in 1970 that in from 3 to 8 years, we will have a machine with the general intelligence of an average human being. Did that happen? No, not at all. And we're still far away from that as well. Now we have new people claiming that this would happen within 3 to 8 years, if you look into the news. So something we see, there were very high expectations. If you make these claims, this will lead to very high expectations. And initially, such promises and expectations that follow could lead to plenty of funding, because government agencies like to fund such stuff. Remember, there was the Cold War, so DARPA invested a lot in technological innovations in the US to win the Cold War. But there are consequences. So there were challenges in the 1970s. Very limited computer powers, computers that just had a few kilobytes of RAM or something like this, made very difficult, very limited memories, very limited CPUs to build such systems. It's something that a lot of people underestimated is a combinatorial explosion. If you have lots of variables with possible values and you combine them. Something that was also underestimated is building a knowledge base for reasoning. So if you want to have an AI that can be as smart as an average human in lots of problems, you would need a very big knowledge base and be able to do formal reasoning in there. And that's something that was definitely underestimated. There is a project, or it's something that was in the news a long time ago. I don't remember what it was called. It was some guy and his research group. They claimed they are still building this common sense knowledge base, and we wouldn't need machine learning, but rather they describe all these rules. But the last time I heard something about this was 10 or 15 years ago. And I Googled it recently, but I even didn't find it anymore. But if anyone finds the name of that project, please share it with me. But it's something that has really not worked out. And something that was also noticed over the years is Moravec's paradox, which is something that was noticed that tasks that are very, very difficult for a human may be very, very easy for a computer. So for example, adding up two very large numbers or multiplying some large numbers, very difficult, maybe difficult for a human, but very straightforward for a computer. But things that are very easy for a human, like natural language processing, image recognition, it's something we do often very intuitively. This turned out to be very, very difficult for a computer. And this Moravec's paradox is something that was also underestimated or not understood at that time, and we're still facing this today. Then, nowadays we use neural networks a lot, but it goes back, that work goes back to the 1950s. So the reference I have here is that the perceptron was introduced in 58 by Rosenblatt, but there may have been other people that proposed something similar or related before. A lot of these foundations in AI, there's actually a lot of often criticism who actually invented what and when. There is a very famous AI professor, Mr. Schmidhuber. Have you heard about this guy? He's one of those researchers that proposed LSTMs in the 90s, so long short-term memories. Anyone remembers LSTMs? So a recurrent neural network for time series processing that was used a lot in this deep learning world until transformers came a few years ago, but was proposed in the 1990s by Schmidhuber and Sepp Hochreiter. And Mr. Schmidhuber, you see him a lot on the internet, and whenever there's, at least what I feel, whenever a new paper gets published, some new concept, he actually claims he already proposed this decades ago. And he is somehow controversial. There's even this verb that someone was Schmidhubert at a conference. So if someone presents something at a conference, expect that there is some criticism coming from him claiming he had proposed that already. But there is some truth to his criticism, because when you look at a few leading deep learning researchers like Jan LeCun or a few others, they often get all the fame for a lot of key innovations in neural networks, but there were lots of other innovations or similar ones before already, but somehow those researchers don't get the fame. And there was, for example, one of the early neural network researchers in the world, one of the leading ones was a German one, Mr. Steinbuch. I guess you never heard about him. He was based in Karlsruhe as a professor, and he made a lot of key discoveries around neural networks as of the 60s, 70s, but he published that stuff in German. So it didn't spread. That's why you should always write all your papers and your thesis in English, you know, so actually can circulate. But let's say the perceptron goes back to 58 by Mr. Rosenblatt. And then in 69, there was a book called Perceptrons by Minsky and Papert, and they showed severe limitations of what perceptrons could do. The term perceptron was mentioned before. Are you all familiar with the perceptron? Someone not? So someone can briefly explain how the perceptron works. Who wants to go ahead? Yeah.
Well, you have several inputs, and every one of those inputs is weight, and you sum all those up together at a bias. Then you have a threshold, and if the weighted sum exceeds that threshold, the perceptron fires and outputs 1. In all other cases, it outputs 0.
Okay, so the perceptron has various inputs. For each input a weight, you multiply the inputs with each corresponding weight, you sum that together, and you add a bias on top. And then based on some criteria. You predict a 1 or a 0. So it's a linear classifier. How does that one differ from logistic regression? Because in the early days, neural networks were called MLPs, multi-layer perceptrons. So you just have layers of perceptrons. But how does the perceptron, because what you described is exactly what a logistic regression can be used for. They actually differ in largely in the training, not in the prediction, the way you train them. So with a logistic regression, you have an error function that is differentiable. So you can apply like gradient descent to find a minimum. But training a perceptron is rather a very unreliable thing because you need to move either the decision boundary in the one or the other direction. So it's not differentiable that you can actually tune very well in terms of the parameters. So that's the main difference. So nowadays, we don't really use perceptrons anymore. We would just use logistic regression units in a neural network. That's why the wording multi-layer perceptron is not really correct anymore. It would be a multi-layer logistic regression thing, something like this. But the perceptron was introduced in that time, and it was noticed that it had severe limitations because it's a linear classifier. So there's this famous XOR problem, which a linear classifier cannot solve because it's not a linear decision boundary. And that was understood. It's in 1969. And this book, Perceptrons, showed severe limitations of what perceptrons could do. And then somehow the field of perceptrons and neural networks lost lots of interest because even if you have very simple stuff like the XOR problem, this could not be solved. Then they wondered how such stuff could be used to solve very, very complex problems. So that led to a big drop of interest in neural networks. And for neural networks, we have oftentimes a synonym in AI, which is called connectionism. So connecting units. But something that was not understood at that time is if you take more than one unit, but multiple units, and you combine them in multiple layers, then it becomes super powerful. And that's what we do nowadays with neural networks. We have very simple linear units, but we combine them, have multiple of them in a layer and then multiple layers, and then we can in fact learn nonlinear decision boundaries. Yes?
Wasn't this also mentioned in this paper?
In 1958, as far as I remember, only one perceptron was proposed. But this book, Perceptrons, I don't know if the book is actually, I haven't read it, if the book was that negative about perceptrons or if the book was largely misinterpreted. But the consequence was simply a loss of interest in this field, connectionism. So I don't know if the book caused it or if bad reviews of the book caused it, whatever, but it led to a trauma. But after this perceptron was proposed in 1958, newspapers, first of all, picked it up very positively. The New York Times wrote on July the 8th in 1958 that a new Navy device learns by doing. Psychologists show embryo of computer design to read and grow wiser. The Navy revealed the embryo of an electronic computer today that it expects will be able to walk, talk, see, write, reproduce itself, and be conscious of its existence. What do you think? If you look at a simple perceptron, is that really possible? I don't think at all, just from a single perceptron. But this is how the news picked it up after this paper was published in 1958. And again, this leads to very high expectations. Obviously, now we have robots that can walk, we have AIs that can talk or see or write, but for that you need more than one perceptron. You need a far more complex architecture, and reproduction is probably a totally different topic. And also for walking, you need actuators and so forth. So expectations. And then after this book, Perceptrons, and you see like 10 or 11 years after this article here in the New York Times, computers could still not really talk, see, or write, or walk. This led to a loss of interest in neural networks. Most of the researchers stopped working on it. But in fact, as I said, the multi-layer perceptrons, but you rather don't use perceptrons, but logistic regression units are very powerful, in fact, and now are the basis of ChatGPT, for example. And what we also noticed was the first AI winter. Are you all familiar with the term AI winter? So AI winter means there was lots of criticism, a lot of stuff did not work out, and financial setbacks. So many promises were not kept, and this led to a major cut to research funding. The literature that I use, I think this was from the Russell Norvig, is the AI winter was defined from 74 to 1980. But if you look in other resources or other parts of the world, this may be slightly shifted. And then in the 80s, there was again a huge AI boom. More funding. Expert systems became very popular in the 80s. So the opposite to learning. And there was a revival of connectionism. So neural networks became popular again. And that time, suddenly, a lot of very interesting applications started to pop up, like chess computers improved, optical character recognition, even some early works on autonomous driving appeared. And a lot of that was funded by the US military, so through DARPA, in which they invest in early innovations with the hope of using them for military applications. Because remember, in the 80s, that was the peak of the Cold War, and the US wanted to win it. So they invested massively. And a lot of these early systems were actually built. Expert systems were popular, but also connectionism, so neural networks became popular. But this also led to an increased popularization of AI. So for example, the first Terminator movie came up in that time. And again, lots of promises, some results. So the results were some progress, but still lots of promises. And probably there was overfunding, but under delivery, which led again to an AI winter. So there was the second AI winter that the Russell Norvig book says was from 87 to 93. Again, major setbacks, many promises were not kept, and major cuts to research funding. And in the early 90s, there was this winter. So this was in the US. I feel in Germany, I'm often told this AI winter was a little bit later, so it was a little bit shifted. But I was just born in that time frame, so it didn't really affect me. But what I hear also from the US or the UK, there were people at that time, they finished a PhD in AI during that winter or just at the beginning of the winter. And they wanted to get a professorship or some researcher position. And they were even told by their bosses, you should remove the wording AI from your CV, it would hurt you. So now we are at the very opposite currently, that you should put AI on your CV, and even too many people that don't have the credentials put it on. But in that time, you were told, don't put it on. I think in Germany, this AI winter was a little bit shifted, but that's a different story. And then after the second AI winter, there was again a huge boom, largely because more data was available from the internet, computing time became more affordable. And something I think we have noticed in that period is that the use of AI behind the scenes in larger systems has increased massively already in the 90s to around 2010, 2011, like use of AI in industrial robotics, logistics, speech recognition, banking, medical diagnosis, web search. Google actually worked on AI ever since the beginning of their foundation. They always wanted to do AI. Web search was just one way how they could use AI. And I mentioned before that Kasparov was bet by the IBM Deep Blue. Concretely, that was in May 97. So Deep Blue became the first computer that could beat the world's leading chess champion. And in 2005, a Stanford robot won the DARPA Grand Challenge by driving autonomously for 131 miles along a desert trail. So that was a huge progress. And there was already a big step forward from 2004 to 2005. So in 2004, DARPA already organized a grand challenge, which was much shorter, not 131 miles, maybe I think 20 or 30 miles. And none of these autonomous systems actually made it. And just 1 year later, there was a much more complex desert trail, and it was won by the Stanford team. And the leader of the Stanford team was Sebastian Thrun, who then made a big career at Google and has become a very famous person since then. And I think that moment 20 years ago sparked a lot of interest in autonomous driving. But let's look again at some predictions that were made. In 1968, Arthur Clarke and Stanley Kubrick, they imagined that by the year 2001, a machine would exist with an intelligence that matched or exceeded humans. That did not happen. And again, overpromised but underdelivered. And there are lots of discussions around other predictions. For example, Ray Kurzweil, he predicted that human-level intelligence will appear by 2029. So when I started this course 5 years ago, we were in 2020. Now we have 5 years have passed. 4 years are left for this prediction. What I see in the last 5 years is transformers are now being used a lot. We have lots of applications. Do you think we will read, or do you think Kurzweil's prediction will work out, that by 29 we have machines with human level intelligence? Yes or no? Yep.
Yes, but not in a general sense. We have machines that, as what I do right now, obviously, like also medics, like your medical patients. I don't think that just 4 years they will come to level intelligence.
Okay. So one student thinks we will not make this by 29 with general intelligence, but today we have systems already in niche areas that can outperform humans. That's, I think, nothing new. It's something we have for a long time. But achieving this artificial general intelligence, I don't think it would happen by 29, but we'll see. Any other comments on this? Fine. So we have now finished looking a little bit at the history and promises of AI. Next, we will explore the deep learning era. So what has happened since 2000, since the early 2000s. We look at some breakthroughs, and we will look a little bit at how powerful neural networks really are. They're the foundation of Gen AI and many AI agents nowadays. But we will also see their limitations, and I will share some best practices when you should pick neural networks and when you should not, because neural networks come also with massive consequences. But we will first have a 15-minute break, and we will resume then with this chapter. Before we continue with the lecture part, there's another thing I received a lot of emails from students who asked details about their internship or these internship accompanying courses, or what to do if they didn't find an internship in time. That's why we had earlier this year this information session about the internship, and many students did not attend it, and then later during the year sent such emails. So there's a reason why we do that information session, and that's why a lot of these emails I received I left unanswered, because all of that was discussed during that meeting, and there's a recording in here from that meeting, and we do it early in the year because then you have enough time finding your internship. There also one thing I want to ask or say is there's the internship accompanying course 2, and the dates are mentioned here, and then I received some emails asking if it really takes place on these dates. Yes, that's why we put these dates early in iLearn. I'm not teaching this internship accompanying course 2. It will be on during that week in March for both the German as well as English language degree program, but it will be done by different professors. And we just hired 2 new professors this term, and they will be heavily involved in the internship accompanying course 2, but they have just started 3 days ago. So we're having a meeting next week to discuss what the internship accompanying course 2 could look like. And they will send an email or an update in the coming weeks. And we will also notify you who is in charge of these courses, but please allow them some time. Just block that week in your schedule, and all the other information will follow because they're quite busy setting up their office and having everything up and running. Yes?
What's the general goal of the thought slide?
The goal has changed over the years. So in some degree programs, what you do is you visit some companies, you do some, you give a presentation about your internship. This is something that is done in a lot of degree programs. It was recently, or it's been recently like this in that degree program, but we had a professor, Professor Eiders. I don't know if you ever met him. He taught the PLV, this internship accompanying to course 2 for maybe 3 or 4 years. He did a robotics lab for 1 week, so 1 week on site with autonomous robots. I guess that's exactly what you guys would like, since you are involved in the Formula student team. But then he left, and then Professor Garman took over temporarily until I see your amusement. Then he stepped in to do this temporarily but he has too many courses anyway. And now we have 2 new professors, and they will take over together with Thomas Evander. I don't know if you met him. He and one of the new hires are doing it in one degree program, and the other new hire in the other degree program, but I don't know in which order. But we're having a meeting next week to discuss this and see whether we continue doing these presentations and visiting companies or something else. And in a lot of degree programs, this internship accompanying course 1 doesn't really exist, but rather you need to take courses like how to give presentations. So this Studium Generale, I don't know, or these general courses they offer about presentation techniques. But I think you don't need to learn anymore how to give presentations and such stuff. So I felt we offer something more helpful for your career and something more challenging. And that's why we have this course here, Innovation Management for AI. Because when I started here, that 5.5 years ago, the German language AI program was just established, but there was nothing really about commercializing AI. I know there's this entrepreneurship module or the introduction to business, but none of that has much to do with AI in that regard. So I felt we should be able to have a course to explore this deeper, building on top of the business foundations you have had already. And that's why I established this course, and I find this more helpful than, I don't know, learn how to give presentations and this. And the internship accompanying course 2, we'll see, it's up to the colleagues. We just discuss the options with them. But yes, it really takes place on the weekend, on that week, and I really don't like emails asking if it really takes place, because that's why we put the information here early. But we'll see what happens. I didn't want to force them into a meeting on their first day here, on the October the 1st. So we said we'll discuss that in the second week. So, and one other thing, it's just a quick ad, but I want to put it here. You have seen my message. We are very fortunate to have CERN, so the European Organization for Nuclear Research, here in 2 weeks again. So they were here last year in spring for the 1-week spring campus. Who of you did the spring campus? I think quite a few here. They currently have 2 of our students doing an internship there, and they would like to have more students from Deggendorf work at CERN. So they're coming here for a recruiting event on Wednesday, October the 15th. There will be some general presentations about CERN and how to work there. There will be a booth, and there will be some gathering and some drinks. So I hope to see many of you, even though you're currently doing an internship. You already need to look ahead, maybe for your thesis or some other opportunities or a summer internship. And I think we can be very proud to have them here on campus in a week and a half. So now we've looked into the history of AI. Now it's time to look at some recent developments, the deep learning era. And we start with some breakthroughs, and then we make it all the way through to AI agents. And you have studied neural networks to some extent already. If you've taken my computer vision course, at least, I know the intro to machine learning does not discuss neural networks much, right? That's why we have this deep learning course in your 6th semester, but we discuss in particular convolutional neural networks in a computer vision course. So neural networks, the idea is we not just have one perceptron, but we have multiple units that we combine, and these units would be logistic regression units. And it turns out if you plug in more and more units in more and more layers, this becomes more and more powerful, and you can learn a hierarchy of features. But this was not always known. So it started with single perceptrons. And there's a very interesting figure I found some 15 years ago in a journal paper about deep learning. And this figure says something like, in the 50s, we see a perceptron. Then people started combining this, and it became super popular in the 80s and 90s. And we talked about these breakthroughs already, like autonomous cars, optical character recognition. But then there was a big drop again of connectionism. So this hype curve does not really cover the first AI hype in winter, but starts, so the red curve starts rather with the second hype in the winter. And then something happened in 2006 that we see made deep learning more popular. Anyone knows what happened in 2006? Yeah. This one goes back to at least the 1980s or earlier. Again, it's unclear who published the first instance of backpropagation. So backpropagation is an algorithm that allows us to efficiently calculate the partial derivatives in a neural network. So we can plug this into some optimization algorithm to improve or optimize the weights. And it was already understood in the 80s and 90s, if you combine multiple layers of neurons, that this becomes more and more powerful. But what happens if I have a neural network with more and more units? Yeah.
And far more, flash capacity. So the hardware below it.
Okay, computing time. So that was limited in the 80s and 90s. What else can happen if I make a very deep neural network? Yeah. Go ahead.
The training data. So
more data, we need to collect data.
And what if I don't have enough data?
Well, then the output will not be that good as it is with more.
Okay, what's the technical term? Yes. Yes, so the neural network overfits. It learns the pattern in the data very well, but it's unable to generalize. And so this was understood in the 80s and 90s, but we didn't have enough data, not enough computing time, and not many smart solutions for the overfitting problem. And then I told you there was the second AI winter. People lost interest in AI again, in particular in neural networks. And if you listen to people who are now very, very famous in AI, like Jan LeCun or Jeff Hinton, they still kept working on neural networks, but they say in speeches that it was so difficult to get neural network papers published in AI conferences at that time, because it was largely believed that neural networks would not work. And when I started studying all of this stuff like 15 years ago or so for the first time, what I found very helpful, there was a lecture recording of Andrew Ng's machine learning course. So Andrew Ng is the one who made his Stanford machine learning course 14 years ago public on the internet, through which Coursera was created. And he simplified his content a bit. So I went through that simplified course and wanted to dig deeper. And then I found that Andrew had recorded a few years before his machine learning course at Stanford. So maybe around 2000, sometime around 2008, 2009, maybe, and put it on YouTube. And then I watched this, and it covered lots of stuff, but not neural networks. That was just, I think, a 2 or 3 minute illustration of a neural network. And Andrew Ng said it's doubted whether this really works, it's disputed. And then this was actually just a time the neural networks were, or soon after, becoming more popular, because in 2006, Geoffrey Hinton published a very interesting paper which addressed the overfitting issue. And what they proposed was you have a deep neural, or they didn't call it necessarily a deep neural net, but just a net with many layers. And I don't think it was pure neural networks. It was rather some Bayesian network or something combined as a neural network in multiple layers. And they noticed with backpropagation that would not work because it would just overfit. And they proposed a pre-training approach. So you would train first layer by layer incrementally by using, for example, an autoencoder technique, or they also proposed something else like some other Bayesian approach. Would need to look up what they called it exactly, but I think the autoencoder became more popular. So they would first train each layer by layer to find some pattern incrementally. First the first layer, then on top from the first, the second layer, from the second, the third layer. And that was the pre-training. And then for fine-tuning, they used backpropagation. And like this, the training went much quicker and with much less overfitting. And this was published around 2006 and sparked suddenly a huge interest in neural networks, because a lot had happened since the 90s. More data, training time became cheaper, plus there were new methods. And over the next few years, this became more popular in conferences, and industry started to adopt this more around 2009, which since then has led to this huge increase in popularity, which we already saw in 2014. And the question was in 2014, so this was a hype curve, where would all of this go? Would it go through the roof? Would it plateau? Or it would totally disappear again? That was a snapshot in 2014. Where do you think we are now? Totally through the roof. Absolutely. So, but it was unclear at that time. And so the idea of deep learning is, because we also have some students here who had not taken the computer vision course. So in classic machine learning, what you often need to do is you cannot train your models on raw data, but you somehow need features from your raw data. And no one really knows how to compute useful features, especially if it's images or audio or videos. There are thousands of papers about different feature detectors, but you don't really know when to pick which one, and it's trial and error, and there may be just not a useful feature detector. Obviously, for some data, you don't need features. You can just use the raw data, but for many cases, you need to pre-process, and you don't really know why or how. And it was noticed with neural networks that they, in fact, for many problems, work on the raw data. And then you have your neural network. And if you have a lot of layers between the input and the output layer, so the left column is the input layer, the right layer is the output layer, and you have a lot of layers in between, these layers learn on their own a hierarchy of increasingly more complex features. So this was from a Google experiment some 15 years ago, in which they wanted to build a machine learning system that can recognize cats and dogs humans and cats in images. Something we use now all day long on the phone. But 15 years ago, this was a big progress. And it was noticed that a neural network could do this the best because we just don't know how to describe with features a human or a cat because they all look very different. And the neural network learned this on its own from the raw pixel data. So we feed in the pixels, and on the right, we have either cat or human. And the nice thing is with vision, you can visualize the individual units. And when you visualize them, it was noticed that the first few layers learn very simple stuff like edges, later layers, groups of edges, and then groups of groups. And this sparked a lot of interest because suddenly the problem of feature description became less important. And this approach can be applied not just to images, but to videos, audio, even text. But we'll look at Gen AI for text later. And since 2006, a lot has happened. We have plenty of new training methods. We have much bigger data available. We can run the training on not just CPUs, but GPUs, so graphics processing units, tensor processing units, FPGAs, so field programmable gate arrays. Then generative adversarial networks came up some 10 years ago. They made a lot of progress. And then it was noticed that you can even combine deep learning and reinforcement learning. And then a few years later, the attention mechanism appeared, which is now the foundation of large language models. So a lot has happened, and I think a lot of that goes back to a single paper in 2006, which turned out to be a big game changer. One thing that very soon after deep learning became popular, just a few years later happened was the company DeepMind. Are you all familiar with DeepMind? Someone not? Looks okay, so I'll just say a few sentences. So DeepMind was founded in 2010 in London, and something that was a real breakthrough at that time was they built a neural network that learns on its own how to play a video game in a similar fashion to humans. So what they fed into the neural network was the pixels of the video game, a pixel stream, and the AI could take different actions like Super Mario, jump up, move forward, down, whatever. And the neural network just initially randomly tried to take different actions, making it to a loss or a win. And they combined this neural network with reinforcement learning, and then suddenly it could on its own figure out after a while which action to take in which state. This led to huge interest, and eventually in 2014, DeepMind was acquired by Google, and Google integrated that technology into its search engine. The main concept, what they did was they combined reinforcement learning with deep learning, but in order to address this combinatorial explosion of possible actions or of possible states you would run in, they combined this with Monte Carlo tree search. And this became so interesting that they applied this approach to many other problems. So remember in 97, the best chess player was beaten by Deep Blue, but the game of Go was believed to be much more difficult to solve. So Go is a game largely played in Southeast Asia. The rules of Go are not important to today's lecture, but in Go, you can take much more actions at a time in a state. And the approach from Deep Blue could not be applied to playing Go. And even around 2012, 2013, a lot of people told me that they wouldn't see an AI beating the best Go players anytime soon. But then with this DeepMind approach, it appeared in 2015 that you could suddenly have a computer program that started to beat the best human Go players. And this again created a huge interest in AI in the news, in particular in Southeast Asia, which was also the foundation of sparking a big AI hype in China, because in China, people play Go, and suddenly you could beat the best Go players with AI, and that sparked a lot of interest in AI in China. But building ever larger neural networks also comes with consequences, because you need not just more hardware, but also more electricity. And already years ago, it was argued how expensive it was to train transformer models. And these were really smaller transformers than the ones we got today. So there was a transformer with 65 million parameters in 2017. Just to train it from scratch, this would cost 27 kilowatt hours. In that time, the cloud compute cost was something between 41 and 140 US dollars. But then bigger models came up, like GPT-2 arrived in 2019, and just training it from scratch would cost tens of thousands of dollars, as well as other transformer models. So we already started to notice in that time, training these models become more expensive. And now if you train one instance of the latest ChatGPT from scratch, probably this will cost billions. And this obviously creates a shortage of electricity. It may contribute to climate change. And that's why there's an ongoing debate now if AI could help us to address climate change or make it worse. What do you think? Is AI overall positive or negative with regards to climate change? Your views, and I guess there will be some disagreements. That's good, yeah.
It's negative, because the energy consumption is just that huge. But in the long term, it might bring a lot of benefits in terms of research and sustainable methods.
Okay, so the first statement was, currently it seems more negative because we take too much electricity, but in the long term, it could help us. Yes?
Necessary to, for example, realize things like big tidal power plants, or maybe gain better understanding of what would be necessary to make an actual running well in fusion reactor or something. So it's a some of investments that now invest these not so clean energy into AI, so that they help us in long term.
Okay. So one comment was that using our not so clean energy at the moment and spending this on AI could help us to spark new innovations. For example, that AI could help us to understand how we can build a fusion reactor. Okay, go ahead.
Recycling, there are many autobots we are seeing, and yeah, AI could be also be used in recycling stuff. So it can be also used for reducing the climate change.
Okay, so AI can help us in recycling, reducing climate change. So I also have mixed feeling about this. So I think if you train a very large neural network from scratch, that takes a lot of electricity. There's no doubt about this. But typically not everyone trains from scratch. And now even companies, when they read such news, I meet a lot of companies, they tell me that they feel they would need to spend billions just on starting to use AI. And I say it's not the case, because there are a lot of pre-trained models that you can just download. Inference is much cheaper. You may have to do fine-tuning or not, or you use RAG or something else. So the cost is not that enormous, just if you make predictions or inference. And I think in some way, these neural networks, these pre-trained networks are also very efficient. Say, we as humans, we spend decades on learning stuff, each and every one of us. We cannot just copy someone's knowledge. But if you train one network, then billions of people can use it for inference. So we actually skip a lot of learning than if like a human needs to learn from scratch. And a network we can just copy. And I've seen lots of innovations that help us to use resources more efficiently thanks to AI. So I worked in engineering before in the bottling business. So, you know, the Kronos group from the Regensburg area. And they now have a stretch blow molding machine that uses AI. So a stretch blow molder uses a piece of plastic, heats it up, stretch blow molds it. So stretches it with a stick and then blows with pressure like 20 or 30 bars, the plastic into a template. And then you have this bottle. And the stretch blow molding process is subject to lots of parameters, even the temperature around. So what you need is a closed loop system. Typically, or say you don't need let's start with the simple system. So initial stretch blow molding machines, you have parameters like the pressure and others, like how much heat, and this needs to be adjusted by a domain expert. Later, they used computer software to suggest these parameters. And over the years, these stretch blow molders got better and better. So they produce more bottles, need less plastic, and so forth. But it was noticed when I worked there. So when I worked at Kronos, I established the AI center there, and we started working on lots of use cases. And stretch blow molding seemed also interesting because they wanted to further reduce the usage of or the amount of plastics PET needed. But if you use less and less PET, you are more and more fragile and more subject to the environment. Say in a warehouse, it gets hotter during the day. And if you just keep the parameters of the stretch blow molder as is, eventually your stretch blow molding may not work out anymore. So you need a closed loop in some way to update your parameters so you have an output of the stretch blow molder, and you have to measure or determine its quality, for example, with some automated process determining if there's enough plastic in various areas like here and there, so your bottle can actually be filled later. And you need to automate this because do you know how many bottles a stretch blow molder may create per hour? So there are some high-end ones, 70,000 bottles per hour and stuff like this. And then you fill 70,000 bottles per hour. So you need lots of resources for this. So there is no human that is able to check the quality of this stuff. So we wanted to build a closed loop system that measures the output of the bottles and then maybe adjusts automatically the parameters. If the quality starts to drop, we amend the parameters. And this is something we started when I was there, and later after I had left, they actually finished the project. And this is now a stretch blow molder you can buy on the market, and so you need less plastic to produce a bottle. And I think that's huge progress and helps us also with environmental aspects, just as one example. But something I'm very skeptical about is whether you should use large neural networks for specific tasks at all, because there's now this belief that you need large neural networks for all your tasks in machine learning. And it's something that I completely disagree with. So there's a reason why there are other machine learning models, say decision trees, Bayesian approaches, and we'll compare them later. But for certain tasks, you don't just need always a huge neural network, and there are other approaches. You can train them on your laptop or your smartphone very easily, and they need less electricity. There are also some hypes and promises now in this deep learning era. I see lots of strange stuff on LinkedIn. That's why I put here some screenshots. So like a vampire is scared of sunlight, Superman is scared of kryptonite, and fake data scientists are scared of research and math. And it's hard to imagine when you get into meetings or political advisory, how many fake AI experts are around there. They have never built any AI system. They have never written a single line of code, yet they claim they are AI experts. So sometimes in such meetings, it's just fun for me to call them out with some questions, you know, how does backprop work, or I don't know, stuff like that, or what is a conditional probability, and they cannot explain that. There's even some blog posts on the internet how to expose fake data scientists with some tricky questions. Feel free to look them up. And there's obviously now in this deep learning era, again, everything seems to be AI, and there is this AI washing. So there's something like the news Microsoft is now using AI to make Windows 10 updates smoother. And the question, so maybe how you could implement this as a joke is obviously if the user is doing stuff and has unsaved work, then you would do the update. You wouldn't do the update, maybe just do the other way around if none of that is the case. But it's not always just AI. Sometimes it's very simple rules, very simple algorithms that are now rebranded as AI. What they're saying like this here, just as a joke, some coding competition, we used machine learning to greet the user with a personalized message. And then you have something like this, that you just say, you read in the name and say hello, the name. These are obviously jokes, but I think there's some truth to that. So welcome. You're 2 hours late. You should familiarize yourself with the rules. If you're late on the presentation days, you won't be able to present. Today is the lecture part. So please look up the recordings because the rules have become more strict. And there's other stuff that you have very high training accuracies, but then you have overfitted and these models do not generalize. And you find so I have now some stuff I find on LinkedIn that I put in here. And when these posts are very bad, I often just remove the name so you don't see who actually posted this. Positive stuff, I have kept the name because those are very good people then. The Harvard Business Review a few years ago published this visualization. So they have a 2x2 learning matrix of skills that they find useful or very useful and not useful and time consuming to acquire or not time consuming to acquire. So what do you think? Also zoom in a bit. Zooming in doesn't want to, somehow the zooming in doesn't work too well, the screen share. So let's start with the easy one. Where do you agree? So I think machine learning is very useful and it's time consuming to acquire. I definitely agree about that. And maybe business intelligence is useful and maybe not that time consuming to acquire. Still maybe time consuming, not that much. Yeah, go ahead.
Is useful?
Yes.
Definitely time consuming. I'd say if you would, right?
Yes, I think data visualization is key to lots of problems, also in an exploratory data analysis, for example. Very useful, but I still think learning these skills can be very time consuming. Where else do you agree or disagree? Yeah.
Statistics as not useful. I don't know how much we have to smoke weed, how much weed you have to smoke to put it on not useful.
Yeah.
But it's actually time consuming.
Yeah, I definitely agree that learning statistics or mathematics is time consuming, but it's the very foundation of all of this. but they claim it's not useful. Or what they claim here is data cleansing. It's actually called data cleansing and not data cleaning, but they claim it's not time consuming and not useful. But eventually all your machine learning is just garbage in, garbage out, if your data does not fit. But yeah, this is what the Harvard Business Review publishes. And, you know, executives, they believe that. And they actually then go to their staff and say, oh, we don't need statistics experts. We don't need data cleansing. We don't need data visualization. And yeah, people remember that. And so this is the advice that you get from the Harvard Business Review, which means to me, they have probably not included any experts in their writing, you know. Then there's, here I really had to remove the name from it because this is also one of the worst things I have ever seen, you know, in terms of advice. And I'm just sharing this because people follow this and I want to discuss it with you. So one person here writes, when AI meets blockchain, and he writes that he recently read some final project that found some report or thesis, and the student offers a brief overview of how AI could be used to deliver bug-free smart contracts that they achieve a certain goal. So can we use AI to deliver bug-free smart contracts? No agreements, yeah. It doesn't work. I mean, all this AI stuff is first of all statistical, and you can never really deliver bug-free software. And I mean, that's what Dijkstra said, that you can only use program testing to show the presence of bugs, but never their absence. So bug-free software is, I think, an illusion. And I mean, there's proving algorithms and stuff like this, but you wouldn't really use AI or statistical methods for that. So that's why I think it's important that in addition to AI, that you have a solid understanding of computer science. And I know AI is very interdisciplinary, and it's great that we have people from other disciplines in AI as well. But I think if you want to dig very, very deep into the foundations and build high-end systems, you still need, I think, a good understanding of computer science. Otherwise, this kind of stuff here happens. Or McKinsey published something, or actually their AI leader a few years ago, where he's not their AI leader anymore, and that's probably a very good choice for McKinsey. They published something like this: machine learning versus deep learning. So the one thing versus the other, and obviously deep learning here seems to be much better than deep learning. Do you really think, than machine learning? Do you think we can really say one thing versus the other? Yeah, you cannot. I mean, deep learning is part of machine learning. But this is the kind of, you know, advice that McKinsey shares with their clients. And then you can wonder, why do so many projects fail? Because this may create the illusion that deep learning was generally better than other methods, and you would not need regular machine learning anymore. The sad thing is, a lot of professors are starting to believe that too. Not here in our department, obviously, but I see a lot of professors teaching largely only now deep learning in their courses, no classic machine learning anymore. And because they feel that deep learning was generally better than machine learning. I've seen lots of professors like this, not here, obviously, but some professors, like I met Stuart Russell last year, so the author of the big Russell Norvig book. I met him in South Korea at a conference, and at a party, ran into him and had a chat, and he told me in his courses he only teaches deep learning now. And I said, yeah, but you know, there's other stuff that you need in reality. And he said, if he didn't teach only deep learning, but if he taught some classic machine learning, the students would lose interest in the course. But I think teaching should never be about whether your students like everything or not. You have to prepare people for reality. And the reality is there's not just deep learning, there is other stuff too. And there's other stuff from machine learning. I think they made some claim that, so McKinsey wrote in LinkedIn, unlike other types of machine learning, reinforcement learning uses algorithms. So only reinforcement learning uses algorithms. Classic machine learning does not. This is what McKinsey also claims. And finally, all of that advice leads to lots of failed projects, because then some executives will tell you, oh, I only want to do reinforcement learning. You're not allowed to invest in anything else. So, or there are other articles on the internet, you don't need math for machine learning. Again, people believe that. And then you have this inflation of AI experts on LinkedIn. Now, let's stop the comedy now and look into some serious stuff. I just wanted to share some impressions, some stuff I see in the market, because finally, I also see that with my clients that I visit me, or when I worked in industry, like when I worked at Kronos, there was some manager of a different team or different group. He didn't know anything about AI, but he claimed he did. And he claimed we would need deep learning for some problem. And I said, and he would only want to do deep learning with me and my competence center. And I said, yeah, well, we need to look into that problem. And then he said, and I said, well, we need to pick the right algorithm. And that guy laughed at me and said, oh, he read on the internet that deep learning is generally better. And that means I don't have any clue. But we didn't do projects with him then. So that's the kind of stuff I don't need. So something we see also because of deep learning has advanced is sort of in the last 2 decades, mainly, we see that, and already a bit before deep learning became very mature, we've started to notice that in machine learning, there's a big focus on big data. And this often goes back to a paper that appeared in 2001 that was about a natural language processing problem. And the paper is called Scaling to Very, Very Large Corpora for Natural Language Disambiguation. I believe what was very, very large at that time is now very, very small. But there's often like a quote. This quote is not written in the paper. This is very important, but it's often a quote that is sort of used as a consequence of that paper. And what that paper showed is the exact algorithm that you would use for the natural language disambiguation was less relevant in their experience. It was rather using more data led to better outcomes in that paper. So a typical like 2 quote from these papers is something like, it's not who has the best algorithm that wins, it's who has the most data. This is something that has also circulated in the last 20 years. Do you agree with that statement or disagree? Go ahead.
Data.
Yeah.
And more data sometimes normally takes with more reliability. Because if you have like 10 gigabytes or whatever of text and everything is just hello world, it's not better just because it has more memory in use.
Yes.
So it's more what is behind the data.
I absolutely agree here. That, or some more input from anyone? First of all, let's see something here. Yeah, one student says there's kind of garbage is still garbage in, garbage out. Yeah. So I would also say who has the best data or the most representative data, whatever. So far, I also taught the big data class. I guess you guys already took the big data course, right? Which actually in the 6th semester, we also look at biases and data quality. If you want to learn this stuff, I'm not any longer teaching the big data course, so I hope someone else will teach this now at the big data course, because I focus on other courses. But there's the concept of bias, that your training data is not representative, and if you have just more and more low quality data with high bias, just more and more data doesn't help. So you need the best data or the most representative data for the problem. I think that's most important, but the exact algorithm still counts to some degree, especially if you have a non-linear problem. You cannot just use a linear classifier, for example, or if you want to have something like a large language model, obviously the architecture, the exact underlying algorithm also matters, plus the data. So that's why I don't fully agree with these two words, but there's some truth to them, but some disagreement. And now we'll come to the question. I've already talked a bit about it before. Is deep learning always the right choice? Because deep learning has allowed us to skyrocket various applications in machine learning. And is it generally better than others? Yeah.
Everywhere have several approaches they can take, and each of these tools has its right use case. They always use machine learning. This always use deep learning mentality. It's a bit like if only tool you have, every problem is a hammer, every problem starts to look like a nail mentality. So that's not the direction to go in.
Mm-hmm. Other comments? Maybe have you tried some experiments on your own where a deep learning architecture did not work well and some other approach worked far better? Yeah.
We had a medical data set and the traditional methods like logistic regression and decision tree were part of it.
Mm-hmm.
The patient had a
Okay. So what other algorithms did you use then? Okay. So I'm just repeating it. One student used for some project in a machine learning course, also used decision trees and other methods, but I'll collect a little bit. You raised your hand?
I think you should, in general, think about whether AI in general is the right tool. So I think you should use deterministic algorithms as much as possible, because they can be tested way better.
Okay. So one student suggests whether you should ask yourself whether AI is the right solution. Maybe deterministic algorithms should be picked first because they can be tested well. I agree here as well. We will later see in detail when to pick machine learning and when not. But now back to this question. So obviously we see that deep learning architectures outperform classical machine learning methods in certain problems, in particular in computer vision problems and natural language processing, in some of them, but not obviously in all of them. And now the question is one better generally than the others? And it turns out there is a very interesting theory about that question. It's called the no free lunch theorem. And the no free lunch theorem, there are actually two of them that were both proposed by Wolpert. One was about optimization algorithm, one about machine learning algorithms. And he already noticed and published about this and provided a proof in '96 that no machine learning model is generally better than others for all possible problems. So say we simplify this a bit and look at all classification problems that could ever exist. Obviously, we will see that some models do better than others on specific classification problems, but they do worse on others, and on those others, other models will do better. So in individual problems, obviously some models outperform the others, but not in general, because they will do worse in others. And in average, they will all do the same throughout all the possible problems. And this was already mathematically proven almost 30 years ago. And I've noticed a lot of professors don't really know that, surprisingly. So you see lots of machine learning classes where even professors claim deep learning is generally better than everything else. Well, it's not, or not in general. And feel free to look at Wolpert's paper from '96. And now, what should you do? Say you have some machine learning problem. Let's, for example, simplify this to a classification or regression problem. So something in supervised learning. How would you tackle that problem? So the way you would not tackle this is directly train a deep learning model on your raw data set. And you're probably not done. Probably you spend a lot of time and money and it won't work very well. So some advice, what I have collected over the years working on many projects. Before you ever train a model, understand your data. So visualize your data, check for biases, do an exploratory data analysis. This is something that is often ignored or gets little attention in a lot of the machine learning literature. So you can buy very nice machine learning books. They look at all these different algorithms, but they don't show you this. Have you noticed this too also in the literature, that this topic gets ignored a lot in the literature? Not in all books, but in most. Anyone notice this or not notice this? How was your machine learning course? Do you do this kind of stuff in the machine learning course? Okay, you're doing it, that's good. Was this a comment or?
Will have us very similar opinion in view of this topic. I actually focuses this course on.
So the machine learning course here does this as well. Good. Any other hands raised? Good. And then now we are still with classic models. For some models, you can use the raw data, for others not. So you may have to think about building features. And then I always advise use a simple baseline, something you can train quickly with a simple model. For example, some linear model for a regression, like a linear regression. If it's a classification problem, maybe a logistic regression or a naive Bayes or something. All of this can be trained relatively easy. And you have a baseline. And now we want to improve the baseline. And you need to choose the right estimator. In scikit-learn, there's a very interesting sheet about which model to pick when. Unfortunately, this figure is a bit outdated. It was created for scikit-learn a long time ago, and meanwhile, scikit-learn has grown, but it can still give you some initial idea. So you're wondering, do you have enough data? Do you have at least 50? So it's for supervised, or not just supervised, actually more than supervised, so also unsupervised. Do you have more than 50 examples? If not, you're recommended to get more data. Is it a categorical problem? If yes, we can go here to the left side. If it's label data, we are in a classification problem based on how many examples we have and other properties. We're in this classification area. If it's unlabeled data, most likely we will deal with a clustering approach. However, if the data is not categorical, if it's about quantities, it's a regression problem. We need to find the right regressor. If it's not a quantity, maybe we have to deal with a dimensionality reduction problem. And based on various properties, this one here recommends different algorithms you should pick in scikit-learn. Anyone saw this figure before or this plot? So I see some. Do you find it helpful? Has it helped you in the past?
In this machine learning course,
Mm-hmm.
and we have discussed a broad overview on this. Yeah, it was quite helpful, but also accurate when we are talking about the individual things.
Okay, so some students have seen it here for the recording. can give you a rough overview, but obviously it's not the ultimate answer, and the library has grown a lot, yet it's probably quite helpful. Now we try to find a different estimator, and we can see if it beats our baseline or not. Because these so-called simple models, they're actually not that bad, and you can train them relatively quickly, and maybe they already give us actually a very good answer. And then if we want to get, and it depends on your business problem. Not every business problem you need 99.9% initially. Say if you're domain experts, so people doing some decision work there, maybe at 80% accuracy, and you can very, very easily build a machine learning model that is at 97%, you have already achieved a lot, and maybe your customer or your manager is happy. And now if we want to improve the accuracy, or say the predictive power, we have to spend more. Maybe the customer doesn't want to spend more. Maybe we spend more and we don't get a better result. So start simple. And I see this also, when I review papers for conferences or journals, oftentimes the authors submit something and they say, oh, we build a neural network doing some work here and we get 98% accuracy. Usually such papers should always be rejected, because you need to try different approaches and compare them and start with a simple baseline. And maybe your simple baseline already got 99% accuracy on the test set, while a huge neural network that you trained is maybe just overfitting and leads to a worse validation accuracy. So start simple. Then try to pick this estimator. And it turns out for a lot of supervised learning problems, some variation of random forests, they do actually surprisingly well. So random forest is, you not just train one tree. So you mentioned the trees before for your machine learning project. Trees are very nice because you can learn decision trees very, very easy. Something we even discussed in my algorithms and data structures course as an application of trees, that we learn decision trees. Typically, from a computing perspective, this goes super, super quick. You can even visualize them, so you have an explainable decision maker. But what could be some downsides of a single decision tree? Anyone wants to share some insights? What can go wrong if I train one single decision tree on my big data set? Yeah.
Many or not enough buckets.
Okay, what do you mean by bucket then? Nodes. Yeah. Okay, and what's the consequence if you have, say, too many? Say we don't have any constraints, we just add something to the tree if needed from the data.
Too many leads to
Yes, so it could lead to massive overfitting, because you have some rare observation in your data set. This may trigger a big extension of your tree if it goes bad. And this could trigger massive overfitting. So there are all sorts of approaches to reduce overfitting in a tree. There are some concepts that you only create new branches or leaves for if there's a certain amount of examples that satisfy this criteria. There is also pruning. Pruning means you cut off the lower layers in a tree, or from the beginning you define a maximum depth, so how long or how deep the tree should be at the very most, plus other things. And the random forest is a very smart approach to tackle this as well, because you split your data in various subsets, and it's not just the examples, but also typically a subset of the features. And then on each of these subsets, you train a tree separately with some constraints that the trees don't get too big. And the good thing is, if you say you have 20 or you have 10 subtrees, this is something you can run very easily in parallel on a CPU. If you have 8 cores, you can train 8 trees in parallel. And this goes quite quick. And when you make a prediction for a classification, you would predict with each tree, which again, you can do in parallel and you can do a majority vote for a regression. So you can use decision trees also for regression. You could calculate the mean or the median or something else from the individual predictions. And it turns out that in practice, these random forests or variations like gradient boosted trees, whatever, they work extremely well. And even though they're not generally better than other approaches, because we have the no free lunch theorem, empirically for real world problems, random forests do well on many diverse problems. So this is something I would recommend to do at one of the next stages. So we start with a very simple baseline model. We could see what next the library recommends. Then we train a random forest, and maybe we're already done. Then a next step could be AutoML. AutoML is something I mentioned in the computer vision course. Anyone uses AutoML sometimes? Well, you should. You've seen it in the computer vision course. In AutoML, we want to skip that manual work of trying lots of different models at a time. So you first try this model, then something else, and you still need to pre-process your data, by the way. So this is something that I could actually add, but not just build features, but also pre-process your data, for example, scaling of your data and that kind of techniques. And with AutoML, we want to automate that boring task of trying different pre-processing techniques, selecting different models, training them, which generates lots of code that we actually don't need. And they're very nice libraries to automate that process. For example, auto scikit-learn, but there's also auto keras and others. And with them, what I say is, I say in supervised learning, I have this supervised problem. Find me a model, either a classifier or a regressor that does well on that data. And a good AutoML library does not just arbitrarily try different techniques, but internally they use machine learning as well to start training a few models. And based on how they performed, they try to use internally some Bayesian machine learning approach to find a better model and a better pre-processing technique. Plus, they also do hyperparameter tuning. So this is something you should use whenever possible, because it will give you a massive speed up rather than trying different models on your own. And obviously the hope of AutoML is that this would cover more and more steps in your value chain in the future. So not just pre-processing, picking models, tuning hyperparameters, but also building features, cleansing your data. There are some libraries for this, but those are, I think, the tasks that are more and more difficult to automate, because cleansing data, understanding data in your exploratory data analysis is something you can hardly fully automate, because you also need domain knowledge. So especially in these early stages, when you understand your data, you need to include domain experts from your customer or the company you're working at. Because if you work on, I don't know, I also had no clue about how stretch flow models work. But that's why I sat together with the people that have been building this for decades. And they told me how they work. We looked at some data, some stuff that I noticed in the data that they noticed. So it's an interaction with the domain experts. Is this something, so many of you are doing internships, are you dealing directly with the domain experts in your project? So factory workers or engineers? Is anyone involved in this? Okay, so what are you doing? Tell us more.
Well, currently, that's what I'm supposed to do later, how setting up. If I'm building a platform to connect to a vector database to cache like those especially more frequently asked questions that come to the devs from from production.
Okay. Okay, so this is something, so you will still rather deal with them. You haven't started yet, but with the people from production. We have some students here from BMW. Are you totally isolated, or you deal with the factory workers or the engineers?
I'm developing an AI agent that should analyze so-called pseudo texts, which describe special parts for individual wishes of customers for a car, and those are written by engineers in the sales department, and we have a meeting next week with them to understand what abbreviations they use, what technical term, and how they should be treated.
Okay. Yeah. So I hope this was recorded. I'm unable to reproduce all for the recording. But yeah, you have a hand raised? Yeah.
The framework for agentic AI, there we want to make like structures of agents which can work together, where everyone in different departments or company is able to make their own agents and also make their own agent structure. So every department can have personalized agents and whole infrastructure for them.
Okay. And you're dealing directly with the customers or the people that will be using the systems?
No.
Okay.
But end of October, it will be like the first prototype ready to deploy. And now we had some meetings where we are talking to the different departments and saying what we are trying to do, what it will be capable of, and then we want from them the use cases and also the data, so we can like give them prototypes to see if it is what they need, and then
okay,
we will introduce more tools like MCP.
Yes. Okay, cool. Yeah, so for these early stages, understanding the data, you as the data scientist, you will hardly always know if all of this makes sense in the data. I mean, there are sometimes things that are more obvious. If like one hell is always data formats, that you have a huge data set and the individual entries have different formats for the data. This is something maybe you can notice quickly. How you fix it is a different question. But if there are other measurements, you just don't know if these values make sense. Obviously, you can look for anomalies. Some people, they tend to cleanse the anomalies, just kick them out. That's something I would always advise against. Like you find lots of advice also in other courses or internet, always remove outliers. Now the outliers mean something. And you need to figure out what they mean and how often they may come. Sometimes you may have to cleanse them and you say, for these outliers, I won't use the model, but sometimes you need them. And so I sit very close with the domain experts and try to understand their work and check if the data makes sense. But if you talk to non-AI people, so say factory workers or engineers, they may not have much understanding of AI, and they may, in some fields, be very conservative. They are scared about job losses. They may be scared that the AI just doesn't work. We later discuss all of this in the contemporary challenges chapter, but don't underestimate input from domain experts for this part here. And obviously later also, if they use the system and so forth, I always sat very, very close with the domain experts. So the AutoML is something very, very helpful, but I don't think AutoML would suddenly automate the whole chain, because especially the exploratory data analysis is hard to automate. And then once you have done the EDA, once you have done the AutoML, maybe then, if you're not happy with your results yet, then look into deep learning. That's my advice. Because once you need deep learning, you need far more data possibly, or maybe much more computing resources, GPUs, and so forth. So don't underestimate the extra resources and costs this would trigger. So I'm not against deep learning, but I'm just against using deep learning as the first possible solution to your problem. Now, we look a little bit into Gen AI and AI agents. The field of NLP got a big shake-up since 2017 when the paper Attention is All You Need was published. Anyone read the whole paper? These are some classic papers in AI that you should read. So from the stuff today, I know I have lots of references and lots of stuff I tell you should read, but maybe read the Dartmouth paper, the Dartmouth proposal from 55, and then this Attention is All You Need from 2017. So what that proposed was a new approach to natural language processing. I mean, we have chatbots and such systems for a long time. Often they were called assistant systems, and they date back to at least the 1970s, but they didn't work very well. Sometimes they were built based on rules, sometimes based on learning. But something I noticed still until 2017 was building a chatbot was not straightforward at all. When you had to build a chatbot, until that time, or even after 2017, before the stuff got commercialized, there were professional tools, like I've used this with my team at Kronos. We looked into chatbots from IBM. You sort of had to define different steps of the chatbot and different interactions you would have with, and then first the chatbot would maybe ask you for your name, then something else, and you had to define all these steps step by step. And most of the time, these chatbots did not work, and next you were unable to really reuse them for some related problem. And this has changed a lot due to Attention is All You Need and this network that was proposed. You have not read the paper. Who has ever seen this figure here? For those who have never seen this, I think that the most important, figure in AI in the last 10 years, and it's everywhere on the internet, and it proposes an encoder and a decoder, and the right side is actually the transformer, so the basis of ChatGPT, T for transformer, and it proposes the attention mechanism actually with a multi-head approach, and with the attention mechanism, you can better find out how tokens belong together. First of all, what is a token? Yeah.
The unit of natural language can be a word, it can be less.
Yes. So in the old days, you would just say a word, long word, short word. And in the old days, what was often used for natural language processing or for understanding text, for example, Bayesian approaches were very common, either for classifying, working with conditional probabilities, later then for example, understanding language in the stream of language. Things like a hidden Markov model were popular for a long time, but they also work with conditional probabilities. Often words were used, and nowadays we speak about tokens. In the simplest way, a token can be a word. In the other way, a part of a word or some entity for a natural language. And there are lots of ways how you can have tokens. You can just use words. You could break up big words, and there are smarter ways that even learn useful tokens from your data. And then you need to find some correlation between these tokens. So how they appear together, typically what they could mean. And for this, the attention mechanism has turned out to be quite helpful. And this is something that was proposed in 2017. So you should also read this paper. And this has been the foundation of many models that have followed in the early days. For example, GPT-2 was something that was common, and GPT-3, then ChatGPT. And now we see all of these other large language models. The good thing is this can be applied to other data as well, like vision. There are vision transformers now, which work quite different to convolutional neural networks. So in a convolutional neural network, we define the different masks, and we say we want that many pixels and that many masks. And with a vision transformer, we actually learn what these masks should look like. So not just what they look at, but what also the size and properties of these masks would be. That's essentially what a vision transformer learns on its own. And for vision transformers to work, so when they came up a few years ago, there was a lot of criticism towards convolutional neural networks, and a lot of people on LinkedIn claimed we would not need convolutional neural networks anymore. Transformers would just solve this. But the vision transformers are helpful, but for them to really work out, from my experience, is you need much more data than for a convolutional neural network for them to really work well. Anyone of you has experimented with vision transformers? I think there were some students last term in a computer vision course that did some project. So again, I'm not against transformers, but they are very helpful for specific problems, but not for all problems. And now, what do you think, for what kind of problems that you have worked on are LLMs useful? Yeah. Improving text quality, okay. Answering questions, expanding texts. What I keep noticing is the emails I get from some students are much longer than they were in the past. So I guess they use LLMs to turn 3 bullet points into a lengthy email. And then we put those lengthy emails in ChatGPT, asking them to get summarized. Yep.
Working with libraries with a way too long documentation.
Yeah, learn documentation, how to work with libraries. That's very helpful. We can use LLMs to generate source code. Yep. Creating tests for code, yeah. Maybe some stuff where LLMs are not useful for. Yeah. Mathematics is difficult because even stuff like add 10,000 and 5,221, sometimes you get wrong results. Why don't they work for math very well? Yes?
Statistics, like they are trying to predict the next outcome. So in mathematics, you have to solve with logic, and here is all like trying to search the data and then finding maybe the next predicted number, but it could be wrong in the data, so it doesn't calculate, it's only predicting instead.
Yeah, for math, don't use LLMs because they just think in terms of tokens, probabilities, which next token. And for math, just use different engines, say Wolfram Alpha, whatever, or Mathematica. They also use some integration now of computer algebra systems in ChatGPT, but it doesn't mean that ChatGPT does all that work. Rather, it uses some other backend and feeds the results back into the LLM output. I saw your hand raised.
So the safety systems, I wouldn't use it because it's just not reliable.
Yeah, safety critical systems is also a challenge. Let's ask, I just have an example here. I was, when was that? Last week, I was in Hanover. There was a very big trade fair, actually the largest trade fair in the world about metalworks. So 13 warehouses full of CNC machines and all of this. So it's an EMO conference. And I gave a keynote there on the first day. It was very impressive. I walked around in, the warehouses there, saw these machines. I also met with the governor of Niedersachsen, so Lower Saxony, in the VIP area. So it was really cool. But these decision makers in manufacturing or investors, they know nothing about AI, and they may ask just the following question to Google. Because we said Google now includes some AI LLM. I'm asking, how can I use ChatGPT in manufacturing? So I presented that last week in Hanover at the fair. And the answer of Google of the AI is ChatGPT can be used for predictive maintenance, quality control, and supply chain management. Plus some use cases here. There are some things where I maybe agree. ChatGPT can be used for workforce empowerment so that we can handle different tasks like drafting emails, summarizing complex information. But can I really use ChatGPT for quality control? What do you think? Would you use ChatGPT for quality control of some manufactured good?
Not ChatGPT exactly, but if we can make a specific AI agents, for example, testing the product, how it is by of the encryption, then we can be used.
Yeah. We would rather need some specific AI and probably not an LLM at all, but maybe just some, something from the computer vision field, be it a convolutional neural network or something else. Yes?
Or it's cross control or for an object.
Yeah.
X-ray scans with ChatGPT and its integrated DLM.
Mm-hmm.
It actually works quite well.
Okay.
You give it specifically do that, and each picture give it a context. For example, these are examples of like coffee grounds or chicken breasts or something. The X-ray scans actually works quite well in these few testing cases you did.
Okay, so one experiment about X-rays and combining this with some context data led to some good outcomes. I'm also not against this, but maybe if you have in some professional setting a quality control, so this also has to go super quick in a factory. Yeah, so your ChatGPT would be too slow. Maybe you also don't want to share all your trade secrets with OpenAI. So I would rather advise here probably to build some of your own model, run it locally. Also because simply of the delays, it's just too slow if you use ChatGPT. But then also other things like LLMs can be used to forecast demand, optimize inventory level. So let's see what others are saying about this kind of stuff. LLMs for forecasting. This is something that has been spreading on the internet now for the last few months. So here's a very positive post. So there's a real guru on LinkedIn, Valery, and he posts a lot about forecasting. And he also posts a lot on LinkedIn about conformal prediction. Conformal prediction is something I taught in the big data class. It helps us to quantify how certain an AI is with its prediction. And Valery, he does, I feel like, hundreds of posts every week about this stuff. If you follow him on LinkedIn, you can learn a lot. He's very skeptical and publishes a lot about why you should not use LLMs for forecasting. The whole architecture of LLMs is not really made for forecasting a time series. So don't do it. If you do it, you will get very poor results in most cases, plus it will be super expensive. And there's lots of traditional methods for forecasting time series. They work far better. There are some neural network approaches, obviously, that also work okay, given you have enough data. But an LLM is really the wrong approach to forecast data. So better don't waste your time with it. And there are more posts from Valery arguing why this doesn't work very well. But the problem is, you have obviously a lot of executives, be it the CEO of the company where you work or your boss or your boss's boss. They may type such stuff here in Google and then ask you to use, for example, an LLM to forecast demand or for quality control. You should explain them quickly that maybe other models should be used, because I, as a consultant, I help companies with this kind of stuff. Sometimes I come in when it's already too late. Someone else tried selling some LLM for forecasting or for whatever, and it didn't work. And I think these examples here, they also show this 95% failure rate. We saw this at the very beginning today. 95% of Gen AI projects fail, MIT says. And I think this has to do with this this exaggerated focus on Gen AI. Gen AI is helpful. We've seen some use cases. Explain documents, compare documents, generate some documents. But Gen AI is just wrong for maybe quality inspection or for forecasting. But a lot of managers and investors, they don't understand how Gen AI relates to the overall field of AI. And I think this is something you also need to be good in arguing when to pick which methodology early to your bosses. There's something you need to learn. So we've looked at the forecasting. And then I have a very interesting thing I just saw a few days ago. Some of you took who took big data already with me? Some did it earlier. Then you remember Ramon, right? Who gave a guest lecture. And Ramon is a very big person at Google working on production AI. And one of my friends we worked together at CERN in the past. And Ramon is a big person, production AI at Google. And he saw some example somewhere, I don't think at Google, but somewhere on the internet, that someone wanted to compare two documents, just how they differ, and just a diff, and used a Gen AI tool just to compare two files, which was 790K, so 790,000 tokens. There was just a few difference in these documents. So don't use Gen AI, just use diff on a command line. Now, Gen AI is helpful. Say you have two totally different, like I sat together on Thursday with financial advisors, investment bankers, and so forth in Austria. And we talked about AI there at a summit. And there are some very helpful use cases, say your client, say for investing or for an insurance, you can pick two different contracts. And these documents will totally differ. Say one contract from Allianz, one from whoever. Yeah. And then you compare them, and they're totally different. There you would not use diff. Obviously, you could use some tool like ChatGPT or some Gen AI tool and say two very different policies. And I have a house that I need to insure or a car. For this kind of stuff, Gen AI is helpful. But if your document just have some changes, some diff, then use diff. Don't use the Gen AI, because this is also leading to this explosion in costs. And I asked Ramon if I can put this here, and he was happy to put the screenshot here. This just appeared a few days ago. And it just was one example of when not to use it. So as I said, if you have two totally different documents and you want to compare them based on some question that you got, then it's helpful. But for other cases, maybe just use diff on the command line, which will run in milliseconds and be probably millions of times cheaper and need less electricity than doing inference on a large language model. Now, something I noticed, I want to share some insights, is obviously this boom in Gen AI is having enormous impact on the NVIDIA stock. The NVIDIA stock is going through the roof. It went up further because Oracle wants to work together now with OpenAI, and they need massive amount of GPUs. And I actually, a few months ago, met Jensen Huang. So, I want to share a bit like what I noticed there. So there was a big AI event from NVIDIA in Paris. And there was a big keynote of Jensen Huang. He spoke to 4,000 people or something in this big dome in the center of Paris. And I think he's a very, very good salesperson. He can present very well and tell you, oh, you need tokens for everything, because if you need tokens for everything, you need more NVIDIA GPUs. That's what he's not telling. But I think he presented some very interesting use cases that they and their clients work on, but probably for less than half of them, you really need a GPU and neural networks. For other stuff, maybe just some traditional machine learning or some, maybe even not AI, but maybe some simulation software, whatever. But obviously, the more people use deep learning, the more GPUs you need from Jensen. But after the keynote, and that's the main reason why I went there was a small Q&A gathering. They selected, I don't know, like 10 or 15 people from all over Europe to sit together with him. And I was invited there, so I sat there too and found this very, very interesting. And but he also possesses a lot of technical knowledge, because I think he studied originally electrical engineering and then computer science. And I think he's an excellent salesperson, but he also knows technical details. So I was very impressed. But obviously, NVIDIA, they're also fueling this deep learning hype. And I'm not against deep learning at all. It's very, very helpful for specific problems, but it's not the right solution for all of your problems. So this was just some of the stuff I experienced when I sat together there with him and a few selected others. It was quite an interesting moment. And they've presented some new hardware, and obviously we'll see a lot of cool stuff coming from NVIDIA in the coming years. Some students mentioned that they are working currently on AI agents. So what is actually an AI agent? How would you define what an AI agent is? Yeah?
It is LLM with a prompt that contains the task it's supposed to do. And you can enhance this LLM by specifying a number of tools you can use, which are basically just functions or API calls. And they each have a description on how to use them and when to use them. And the LLM can decide, and gets input, and can decide when to call which tools, or if to call any tools at all, and with which parameters.
So the first answer is like it's an LLM that can also trigger certain actions depending on certain events. Any other definition? Well, we will do a 10-minute break. In the meanwhile, you can think about what an AI agent could be for you, or if there are other definitions, and then we'll look a little bit into them. So see you in 10 minutes. So in the meantime, you may have had some time to rethink about how you define an AI agent. We had heard something interesting already. Anyone who agrees with that definition of an AI agent we heard before? Or any other definitions? Yeah.
Can generalize it to just a system that does things on its own.
Okay, a system does things on its own. So I'm not too happy with the wording AI agent, how it's recently being used. Because first of all, that term is nothing new. If you look in classic texts like Russell Norvig, the wording AI agent is there for decades, and it just means the actual AI that does something. And that term was popular at some point, and in the last decades, I guess it was not used much. You may have seen the term in an intro to AI, at least if the book is maybe close to Russell, or if the course is close to Russell Norvig. When I taught in the past, before I got my professorship here at a different university, the intro to AI on the side, we used those definitions because Russell Norvig, they define an AI agent, the environment, and this kind of stuff in one of the first chapters. And then the term disappeared, and now AI agents is a term, but it actually means something different. First of all, I feel everything that an AI does is now an AI agent in this marketing hype. And what is really behind it is a bit unclear, because some people now, they just before had a machine learning system, a predictor, now it's an AI agent. What you said is something I find quite helpful, like it's an LLM that does something concrete, because an LLM is useful, but it generates some text, for example. But what is the follow-up? What am I doing with that information? Because oftentimes this has to lead to some concrete outcome, maybe send out an email, move some file, trigger something, whatever. And this is, I think, what is often understood behind AI agents, that you have these LLMs that trigger some concrete action. Then there's also the wording agentic AI. What does that mean? Maybe to some people, agentic AI just means AI agents or further automation. But again, these terms are loosely defined. if you ask ChatGPT or before the old Delhi version, what is an AI agent, then you get something like this, also not very helpful. And I feel a lot of providers of solutions that do robotic process automation. So RPA, robotic process automation, is a term that was very popular about 10 years ago, which meant that you automate workflows in a company. In that time, it was also believed that all of this would suddenly happen automatically and all the work would be done. Well, this has not happened, but a lot of RPA providers like UiPath, and there are many others, they have now also changed their wording and they claim they do AI agents. So from some perspective, you can see an AI agent is maybe some combination of robotic process automation and machine learning. But again, that's nothing new, because 10 years ago, when this robotic process automation was very popular, a lot of them already claimed that they would include AI. So you see, it's just wording, but obviously there are some helpful things. Some of you mentioned you are working on AI agents. Can you tell us a bit more again what you're doing? Yeah.
This case is to analyze texts which are written in some kind of structure, but it's basically natural language, and those specify certain parts.
Mm-hmm.
And the agent's job is to find all those parts and bring them into a structured format like JSON.
Okay. I guess since you're close to the mic, this was recorded. Then you also talked about agentic AI, right? Can you tell us again what you're doing?
Automated systems for the different departments, for example, for HR, which has many like repeating questions from the teams, and they want to automate the answers. So we need, on the one hand, an LLM, which is the base for which the people can talk to, and this LLM takes then a reg agent.
Mm-hmm.
And this reg agent, like you give it an input where to find the connections, and then it makes a connection to the Chroma TV and gets the output. Then there's another element which has the context to summarize all that and gives it back to the user.
Okay, so you interconnect some of these systems, and that's what often then people also refer to as agentic AI. That's not just a single AI agent, but multiple. So you're working on AI agents or agentic AI for work in HR. So I've just, yeah.
It will be spread to the whole companies of different departments. For example, in finance, we need predictions, and then we also have some machine learning models for the predictions, which are a different agent.
Mm-hmm.
So we have in the base every time an LLM, which the user can talk to, and the LLM will then connect with a different other agent which have like tools like MCP agents, for example,
Mm-hmm.
Connect to the internet or connect to a database or
yeah. Yeah, but you still need to manually program all of that. It's not or define. It's not suddenly the AI agent would, magically come up with a solution to all of this, and you still need to define certain workflows or actions.
Yes, but the goal in the end should be, for my boss, he wants to make it that we have agents everywhere, and one agent is like then not having a structure. He can say he wants to use now that agent and that agent and that agent on its own,
Mm-hmm.
or even create an agent with templates.
Okay.
So now our framework is like we want to create templates for every agent, which the input is in the database,
Mm-hmm.
and with that input, maybe later an LLM can then access the database and create own agents.
Okay, so I repeat this, the long-term vision would be that the LLM would also steer the agents, but also create new agents to do something. Currently, I think most of the work around AI agents looks something like this. You still define the workflows, and obviously you have some great concept, but in the news, these AI agents are often sold like it's all happening on its own. You don't need to do anything anymore. And I would also be very scared about something like this, you know, running this on my computer and maybe just deleting my files because the LLM, you know, predicted some wrong token. So I guess all of this has to be taken with some care. It's very, very helpful stuff, but I guess it's a bit different to what you often see in the news, or at least in popular articles about how powerful this is. But it's great you have some next steps to work on. Yeah, so this was the deep learning era. So we've explored a bit some breakthroughs, how it all goes back actually to one paper that helped better training neural network architectures. And we've looked at promises and hypes, but also bear in mind the no free lunch theorem. And you should definitely read the Attention is All You Need paper if you have not done so yet. Now, we will look at some concrete steps of how we can advance AI in a company. I already got quite a few questions about the lunch break, so we'll start with the lunch break around 12 today until 1. Please be back shortly before 1, because at 1 we have our first guest speaker. So we'll have guest speakers in the afternoon, and we'll see how quickly they finish, if I still then teach something or if I continue tomorrow. And we'll just see. And tomorrow at 11, we have Christoph here, the former board member of Siemens Healthineers. So we'll definitely be teaching tomorrow from 8 to 11. And then we see how long Christoph's guest lecture takes and what content I have left. What I notice is the slide deck is getting longer and longer every year. So when I taught this course for the first time 5 years ago, it was about just under 100 slides. And now it's just doubled. So, but it's also more insights, and it's a lot happening in the market. Yeah, we will now see a little bit opportunities for AI in companies. We will also see some challenges, and we will see some best practices. So the big question is already that I notice when you go to companies where someone wants AI, the big question is, what is AI? And again, the news, everything seems to be AI. Something I keep saying oftentimes is that AI, just for, you know, if you go to customers, you can't be just speaking super technical language. You need to somehow address the decision makers or non-AI experts. So what I say is that AI is about automating or supporting human decision making. This is my explanation in one sentence, how to trigger executives. And then there are actually some studies, they claim that humans make up to 30,000 decisions per day. It's hard to imagine, be it in private life, when driving, when choosing what to drink. But at work, it can be writing emails, writing code, selling, defining prices, forecasting, controlling some factory equipment, and so forth. And that's at least how I start saying what AI means to me, but there are lots of other ways you can obviously explain this, but don't be super technical when some manager invites you, you know, don't just say for 10 minutes how a neural network works. Yes.
Conscious decisions, so like sub or does it be unconscious decisions?
As far as I understand, also the unconscious ones, but the figure is not from me, it's from some publications, but there's also some dispute what a decision is and what it's not. Yeah, and I just remembered something that I wanted to say about before we continue with this chapter. It's actually a previous chapter about the AI agents. I was also quite busy with some unexpected work about AI agents during the summer break. So usually during the 3-month summer break, what I do is preparing slides. I do some consulting deals through my business. I travel, read some new papers, some new books, try out some AI on my own. But usually the August is a relatively empty month when it comes to my consulting business because customers are typically on vacation. So I focus on reading, creating some slides, spending time with my kids. But during this August, I was kept super busy with AI agents because now what I notice is, since there are more and more companies doing AI, there are also more and more lawsuits. And obviously the lawyers are very happy about this and they want more AI lawsuits. But there was a very complex lawsuit starting in the US between two AI companies, and it obviously also got into courts in Europe. And then this started appearing during the summer in Germany. I'm unable to reveal a lot of insights about what happened there. Some of it in the news, but not too much actually. It was largely like a trademark issue. The two AI companies used the same wording. Maybe you can, all good?
I don't know.
So you're unable to silence your phone, or what's wrong? Yeah, maybe just shut it off then. Yeah. And these lawsuits are obviously, so problem solved, right? Oh, fine. And so there was this trademark issue between two AI companies. And so they need lawyers to handle this. And obviously in each jurisdiction, you have different courts. It needs to be sorted out by the national courts. And one of these two parties or their lawyers, they contacted me. So I don't know much about trademarks. For this, you need lawyers. But they needed some expert review from a technical perspective and from a perspective of the markets, customer segments, how these two AI products actually differ, because they address some totally different types of user. One AI tool was more for an AI solution to help software developers with AI, while the other tool that had the same name addressed rather general users, like a general public that everyone could use. And then I was asked to write a review how they actually differ from, first of all, the technical stuff, what they do, plus which customers they address, which market segments. So this kept me quite busy during the summer break unexpectedly. We even had to reschedule one of our vacations. So my wife was not very happy, but believe me, the customer paid a lot. So I told my wife we need to reschedule one short vacation because there was a tough deadline for the trial. But finally, the trial did not happen because I was also prepared to go to the trial as an expert. But the two parties had also arbitration ongoing, and then my expert review helped my client to finally win the arbitration. So my wife was first not happy that we had to reschedule a few days of the vacation, but I can tell you it paid a lot. So my wife finally understood, and I was more busy during the August than usual, because usually the August is for me to relax and read some stuff. But I also learned a lot about this, about these two products that they use, and one of them I could look very much into details. And finally, my client won, so we're very happy. And I sat together in the summer with just a lunch break with an executive who was a board member of a very, very large company who wanted to meet me. And I told him this during the summer break. I told him, oh man, we had to reschedule the vacation, and then he said, he knows this. He once had to reschedule his planned wedding, So the more you go up, this happens. And he said he was just one level below the executive board, and then the supervisory board told him he would be considered to become, I think, the CTO of the company and get elevated to the board. So they invited him for a 1 day of discussions. And that was the day he was supposed to have his wedding. To reschedule this. So, and then I told my wife this, look, I just met this guy who had to reschedule his wedding because of business, and then the vacation thing is finally not that bad. But yeah, you need to make that compromise. So if you want to make a career, you cannot just sit there from 8 to 5, turn off your phone, whatever, because if someone important tries to reach you at midnight, and that happens a few times, these people will never call again. So, and it's obviously, if you want to get promoted, you need to work more. But finally, you can also make more money, more traveling, seeing interesting places. Sometimes weird stuff comes in. I think also end of July, one of my clients called me and said, "Oh, we need you in Hong Kong in 2 days for an event." And then I said, "Fine." We just discussed the terms on the phone. And, you know, they called, I think it was pretty late, and said this would happen in 2 days if I'm available. I said, yes, but if your phone is off and you wait until get up in the morning, or you don't check your emails in the night, they will never call again. So that's why if you want to make a career, you need to put in lots of effort, but it can be very rewarding, not just in terms of the pay, also the kind of people you can meet and stay in nice hotels, have, I don't know, if you ever fly first class, that's an experience, you know, stuff like this. So it's all, and that's why also I want to give some career advice before we continue with this chapter. So many of you here are doing your internship, and next you will do your thesis, and then maybe you will do a master's or not, or a master's later. While you're still young and you don't have kids and a house and all of this, try to change jobs a few times before it's too late. So, and I think especially what can be super rewarding after you graduate, you work in consulting. And consulting is not just McKinsey creating strange slides like machine learning versus deep learning, but there are also other, obviously, consulting firms that do more technical work. I think consulting, I've also worked in consulting in the past. It's fun because you get to see lots of different projects, lots of clients, you work with lots of people. It's very time consuming and you probably need to travel a lot, but you also get to meet very interesting people, and you learn very quickly how to sell stuff because you need to convince your clients quickly about the results, and they may need more help, whatever. And after a few years, maybe you can switch to one of your clients. You can get maybe a more advanced position there. So because you know them and you have, because in consulting, you learn far quicker than if you're just in one company in the same team for 5 years. And so my advice is, if you want to make a career, see lots of stuff, apply AI very quickly to lots of stuff, work in consulting. It's probably, for an entrance position, doesn't pay that much more, because there are also consulting firms, they don't pay that great for juniors, but it's an experience. And I see this now myself. Now I have 2 little kids at home. It's more difficult to travel, and I can't just be away for 3 weeks. But if you don't have kids, you can do this more easy. Now I have a house, and it's even simple stuff like gardening. You know, I can't just even if I take my wife and the kids with me to a project, we can't just disappear for 1 month, because we need to look after our house, our garden. Recently, we had some issue at the roof, and it started to rain into our house because there was a wind that blowed off some tile. So you can't just be away for a few months, otherwise you return and your house is broken. So we just called a worker and got it fixed. But you're young, you don't have all of these obligations yet, or probably most of you don't have them yet. That's why seize the opportunities, travel to other places, and consulting is a great way to do that. And it's very time consuming and exhausting, but when you're young, you can also do this more easy than if you're, I don't know, 50. And then the question is whether you want to stay in consulting or not. Obviously, if in a lot of large consulting firms, the hope is for those who want to stay, they want to get a partnership. You know what a partner in a consulting firm is? So someone who owns part of the company. So you, in consulting, you climb the ladder. You start maybe as a junior, then you become an associate, senior, director, and at some point there's a partner scheme. And it starts as a salary partner, so you still get your base salary. but then there is equity partnerships and typically multiple levels. And when you become equity partner, you need to buy a small share of the company, which is typically quite some money. So a lot of those who become partner, first of all, need to take a loan, unless they have made some considerable savings. And probably your base salary won't be that much anymore, but you get share of the revenue or share of the profit. But you will not really have a life anymore because you need to be available 24/7 for your clients and your teams. And when you're a partner, your work is not really about anymore doing much of the consulting, unless it's some very special stuff. Mainly it's selling, relationships to your clients, going to luxury dinners and this kind of stuff, and answering quickly. Some people like this, and there are partners, they earn millions every year. We even had a professor here in our business department. He's a very strong person in AI and supply chains. He got bored here and he returned to consulting full time. So he worked at McKinsey and then he quit here after 5 years, after 5 semesters as a professor. He just didn't feel challenged anymore and returned to a very influential consulting firm, and he's back to that life and probably on the best way to become partner very quickly now. But he does not have kids yet. So don't underestimate this. End up becoming a partner in a consulting firm will most likely also trigger at least one divorce in your life, maybe more. So, and I see that not with my friend, but I see this with others, you know, and I hear strange stuff like the CEO of a very large consulting firm had a wife, he had a girlfriend, plus he met someone short-term at the last Christmas party, and now they're expecting a kid. So this is the kind of rumors in the consulting world. So it's a very shady business, but obviously some people behave fine. And I'm not recommending to stay for partner level, but at least spend a few years early in consulting. You get to see lots of projects, lots of clients, and your learning curve is much more than if you just sit in the same team for a few years. And now while you're young, it's still easier to do that. So after we talked about consulting, we've talked about what AI is. And now say you would introduce AI in a company. There are 2 directions you can take. One is either along your value chain. So your value chains means you introduce AI in your internal processes. So value chain is like primary functions like sales, procurement, you have R&D, you have supportive tasks like HR, whatever. So this is all your value chain. This is one direction you can take with AI. And the other direction is you put AI in your products or services. So you would eventually use your products or services and AI to support your customer's value chain. What do you think, which direction you should start with? Say your company doesn't have any AI yet. Which one would you start and why? Yeah.
Maybe some kind of company-wide rollout of a large language model.
Okay.
For normal workers to use. And also you have to have some kind of tutorials on how to use it.
Okay. Would this fall into value chain or products? Yes. So this would be a clear example of the value chain. Yes.
Quality control sector or something.
Yeah.
Classical computer vision. And it probably makes sense before you do like a lot of background automation here coming in. You build some AI expertise company by integrating it into your products.
Okay. Experience, yeah. Yeah, so the first comment was maybe roll out an LLM for everyone in a company that would be value chain. Well, you say if you have already products that include something related to AI, maybe some traditional computer vision, it could be easier to put AI in that product there. And I think there's truth to both of that. So what I notice is obviously over time you should take both directions. The value chain is often the one you look at first because you have access to your internal data, to your systems. I know all of this may be challenging, that you have silos and all sorts of internal politics. But oftentimes, if you start optimizing your value chain, even if it's quick wins, it generates some relaxation or some capital that can be used for some other work. So the value chain is often the quicker one, and there is less stuff you need to worry about. Obviously, there are laws that in compliance that you need to follow, but for example, when you just use your value chain, you don't need to think about marketing or sales or pricing yet. However, when you put this stuff in your products, you need to think about how you market it, how you sell it, how you price it. Plus, there are probably more laws you need to pay attention to, like product liability laws and this kind of stuff. So from that perspective, it's often a bit more challenging to integrate this in your products. However, there are some examples, as the one you mentioned, where you could maybe integrate it very quickly in an existing product. I often recommend, though, to start with the value chain. But whatever direction you take for an AI project or a transformation is, you need to be able to measure your processes, how good or how bad you are. So you have some tasks, say some forecasting that you do, or some task dealing with cases coming in from your customers. You need to measure how good or bad you are. Measurement could be how long does the task take, or how bad is your forecast, or how much time do you spend on the forecast. And then when you build the AI and you deploy it or you test it, then you can measure how good or bad you are again. So whether you have actually improved or not. So you need metrics or KPIs, key performance indicators, early before you actually start building your AI, because you need to measure whether you have finally improved or not. So with the example that you mentioned, that we integrate this in some computer vision system, you would need to measure how good or bad are we, and then we build the AI and then measure again. And if the accuracy has, for example, not changed, then probably we've made a loss because we've spent more money on it. Maybe we need to put more hardware in this device to run the neural net. So these metrics are often quite complex, and the metrics are not just accuracy, like 99% accuracy. They are also important from a business perspective. So how much time, how much cost, what are the consequences? That needs to be considered. But even from the pure AI perspective, which metrics should you use? And I again have some LinkedIn conversation. There was some discussion a long time ago on LinkedIn, which metrics you should use in machine learning. So I'm not talking from business, but from machine learning. And what I often see is some people say, oh, my model is 99% accurate. Or I see this, some work gets published and the precision gets picked, or the recall, or something else like AUC, whatever. But just picking a metric and saying how good you are doesn't really solve anything, because in the real world, you need to argue, why have I picked that metric? Why does it address my problem? And is 99% enough or not? Maybe for some problems, 95% is enough. For others, you need 99.999, whatever. So I know in a lot of machine learning literature, people just pick accuracy, but your accuracy already is flawed if your data is imbalanced. Meaning you have a different amount of examples per class, your accuracy doesn't mean anything. So you need to correct for that. But there are other discussions. Someone claims, the post was specifically aimed at beginners and one shouldn't waste time telling which other metrics are useful, and one should just use accuracy, whatever. But there are more discussions also here. Valerie posted something, one metric that has become very popular in the past is the area under the receiver operating curve, AUC. And people use this because it's not impacted by imbalance. But finally, the AUC is a number that you can tweak, but it doesn't mean much or it's hard to explain to a manager what it finally means to them and if they make money out of this or not. So it's maybe from a comparison of model performance interesting from a machine learning perspective, but the AUC is not very interesting from a business perspective. And you need to build that bridge thinking about what added value does it return to the customer or my boss, whatever, if I have this AI model and it does something well, and how can I sell it? So there's no universal recipe to this, but don't just tell someone I have 99% accuracy or 95 or 0.95 area under the receiver operating curve. And now we come back to something we discussed very early today is when should you actually use AI? And what I see from a consulting perspective is the following. So people are super fascinated about AI. And for example, when I started working at Kronos, and my first day setting up the AI Competence Center, it was very interesting. It was my first day at Kronos. I told my wife, I'm coming in. They asked me to come in at 9. I'll be, at home at 5 probably on the first day, but set up my phone, talk to my boss and discuss the next few steps. Finally, I came home at midnight and I had not set up my phone. So because a lot of other managers just wanted to talk to me and discuss potential use cases with me. They had collected all sorts of ideas and what we could do with AI, and we discussed all of that until midnight. And I still didn't have a phone set up or anything. So people are super fascinated about AI, but is AI always the solution? And from a perspective as a professor, I'm very fascinated about AI, but from a consulting perspective, I'm more cautious because I come to a lot of companies every year. They tell me, we want to do AI. And I guess you've heard such stuff too. And I ask, what do you want to do? And then they say AI. And I ask, what exactly? Then they say, oh, we have a data set here. I ask, what are we using the data set for? They said, oh, we don't know. The AI shall find out. So this is something that a lot of executives actually believe that this really worked. And there's a big risk around that approach. The risk is that you're not actually, so you're coming with a solution, the solution being AI, but you're not solving actual problems, but rather you're creating problems that had not existed. Because when you introduce AI, you need some extra infrastructure, your extra costs, data, whatever. And then you don't really know what you're addressing. So from a consulting perspective, I prefer a different approach. And I say, what is it that I want to improve? And then I want to improve this as simple as possible. Sometimes maybe a few rules are enough for a decision process. Yes?
Major problem is that many companies don't want to do something with AI, rather than don't use the connection in the market with AI. I think most companies are like, oh, and other companies like having AI in the product. So we need a tool only to say in the market that we have AI, not to improve really something. So I think that's the major problem there, that many of the salespeople don't even know what AI is capable of and what AI is not capable of.
Yeah, I like that point that companies want to add AI to their products because their competitors have added AI too. But that could often lead to AI washing, as I mentioned before, that simple things are just reprinted. But what I see is we need to solve concrete problems as simple as possible. And sometimes you need to rethink maybe a business process from scratch. Maybe you have too many mutual dependencies, whatever. and you first need to fix that, or first actually describe a proper business process, because a lot of companies, they don't have properly defined business processes for their problems. And once you have done that, maybe on top the AI can help. So it's human intelligence first and then the artificial intelligence. Yet there are some criteria when AI can be helpful. For example, if a decision process takes very long, humans need to do something manually, do some calculation, need to write some code, type some email, design something, may take days or weeks. An AI could lead to a massive speed up. Even if the AI does not fully automate it, but give us maybe a 95% solution. That's one thing. Then another factor is costs. So things are expensive, or processes are expensive, because humans spend time on them, but there are maybe other factors that contribute to costs, like say you have a cleansing process and you need acid for that cleansing process. So you use maybe more acid than you would have to, which leads to extra cost, extra impact on the environment. Maybe an AI could help us to reduce this. And the third one is uncertainty. Uncertainty means you have some decision problem and two domain experts decide on the same instance differently. Have you seen anything like this, like in the companies you're working at? For example, quality inspection, you may see this, that something is produced and then you give it to two experts in quality inspection and they decide differently, or you give two engineers a task to design some machine and they come to totally different machines based on these requirements. So that's what I call uncertainty. And here AI could also help us to maybe have more homogeneous decisions that we make rather than very diverse ones. But solving this uncertainty issue obviously requires, or usually requires, lots of work and is not straightforward at all. For example, again, from the bottling business, I have a good example. A friend of mine, he worked at a competitor of Tetra Pak. So Tetra Pak, you all know this kind of container. So I just say now Tetra Pak, even though he didn't work there, but just to refer to this kind of container. And he said they struggled to actually measure whether a Tetra Pak is well glued or not. Even the domain experts disagreed. So they produced the Tetra Pak, then cut it open and somehow put it under a camera. And they wanted to automatically assess whether the clues are done well or not. And the domain experts disagreed largely. And then they collected the data, we'll get to that in a moment, and they built an AI, and the AI did far better than humans. And then I asked him, so he said, that's really cool. And I asked, what did you do? And then he said, oh, yeah, they collected the data, the experts assessed these images. And then I asked, yeah, how? And he said, one was super engaged and he contributed most of the labels. I said, well, your AI has just learned that person's decision behavior, but it's not necessarily better. And finally, you have largely this person's label in the data. So I don't think that would really work. So what you need to do is, and this is the difficult task, you would need to bring the domain experts together, give them the same examples, let them sit together where they disagree and have them achieve some consensus, which is hopefully possible for most of the instances by discussing. And then you have a well-curated data set from which you can actually learn. Otherwise, if one expert contributes more labels than the others, you just have a major imbalance in your data. And I don't think it will lead to anything. There are also all sorts of challenges when you want to introduce AI in a company. There's always this big question, who is actually in charge of AI? Again, here's some historic developments. In the early days, in companies, it was common that maybe the IT department would be in charge of AI. The question is, should an IT department be in charge of AI? Because They may be more conservative, more think about reliability rather than innovating. If you let every team build their own AI, this can also lead to chaos because you somehow need to coordinate, establish best practices, the same infrastructure. So you need to allow some freedom, and you need classic IT, the IT department, in part of that discussion, but they should not necessarily be driving it because they may just think about safety, making things run, or they are good in running things reliably, but they are not good in innovation. And in a lot of companies, innovating is awfully difficult. In a lot of companies, you just get a laptop with an user account. You're even not allowed to install one extra Python package. So you need some other development infrastructure. How does that work at BMW?
It's very restricted what you can download and what you shouldn't.
Yeah.
Must.
So very restricted.
Yeah, as a developer, you have freedom to some degree, especially with administrative rights. But the default user is, yeah, pretty restricted.
Good. But then if you have admin rights, you're connected to some other network or some other environment and all of this with your machine.
Yeah, so some.
Yeah, because we've seen this too. So so before we switched to lunch, when I was there at Kronos, I noticed that very quickly that everyone got these Windows laptops and we had no rights, and you could install one thing, and for this you need a one-time permission. But then, you know, we started hiring people, and everyone needed maybe hundreds of Python packages, and then everyone for every package would need a separate permission. So, and they wanted to offer virtual machines, but the IT department was not there at that time yet. So we actually everyone got a second laptop, and we installed Linux and administered them on our own, which was fine. And we connected them to the developer network. And it all worked until one of my interns started connecting his Android phone to the developer network, and he had some virus or something on his Android phone, and we got that into the developer network. So that was a very sad thing. So it's complex. And in other companies, maybe they have specific development environments or virtual machines. So there's not that one solution that you could apply to every company. But many of you are doing internship. Are you facing this? Some restrictions there, what you can actually install? Or you can just install whatever you want? Yeah, it depends also on the size of the company. Often maybe a smaller company is more open. Bigger ones are more concerned about cybersecurity. And with that, we will switch to the lunch break.